No.
No?
Yeah.
Yeah. Okay. Thank you. So we'll do a quick recap what we have seen yesterday. We have seen yesterday on regarding Docker. By using Docker, how we can create our application as a container. After that, how we can convert that container as a image. After that, how we can pull that image to our registry, that is Docker registry. Whenever we need, how can we push that to Docker registry? So whenever we need, how can we pull that image? So all those things we have seen yesterday. One thing just I will update you, yes, regarding multi-container yesterday. So I forgot to tell. See what happened here in the multi-container when you are running. Okay. Before that, see to practice, some people's may don't have AWS account or they will create or already they created, but now they don't have some any other user ID. Some problems are there, correct? So to do best practice about Kubernetes, we have here killercoda.com is there. Okay. If you go to this killercoda.com, it will provide you playgrounds. Okay, this is the login page. Once you log in, you can log in with your credentials. Okay, you can Gmail credentials. Okay, once you log in, then you click on playground. So sorry, yeah, playgrounds. Then you click on Kubernetes 1.32 or whatever is it, but you take this one. Okay, 1.32. So if you open this, they will give you ready-made cluster. Okay, you no need to create accounts and do all those things in AWS. Why? Because it will be cost. So first, if you want, you can practice here. You can practice here till cluster IP, which I'm going to explain today. So till cluster IP, you can practice in Killer Coda itself. So when you start, then it will give you it will give you the cluster. If you go and check here, kubectl get nodes. See here it is control plane is nothing but your master node. This one worker node, one marker master node and one worker node it is giving. It is quite different. Why? Because in EKS cluster, we are not accessing master directly, correct? So we are working on only worker nodes. First here, they changed this master node itself as a worker node. Okay, so you have two nodes, you can play around it. For example, if I want to create any container, so vi something like pod.yaml. Okay, so I'll copy this multi-container. So I copy this code here. What happened? What I did? So API version v1 pod. I'm going to create pod object. So name this name whatever you can give as we discussed yesterday. And inside the specification, we are declaring two containers. One container name is Nginx. Another container name is Tomcat container. Okay. Nginx we are declaring code for Tomcat. We are not declaring any codes. Let them take randomly. Okay. We don't want any specific code. So just I save this. Then while running, what we need to run? kubectl apply -f, then pod.yml. So pod will be created. kubectl get pods. So if you see here, container creating stage, it will quite slow with compared to EKS. Why? Because this is free platform, correct? So it will take some time to wait. Let it wait. So once it is created, yesterday what we seen in the sense, what we missed in the sense, we inside the pod we deployed or we created two containers, correct? Yesterday we logged in the pod, but I have not tell you how can we log in a specific container itself. Say for example, yesterday we logged into the pod here in this place and we see both the containers, but today actually we will log in into this C1 container, or if you want we can log in into C2 container. In our example, C1 container is Nginx container, C2 container is Tomcat container. So now I just in quick within 1 or 2 minutes I'll show you how can we log in inside the container and run some commands if you want. Okay, so I'll go again. Let me check whether my pods are created. Yes, it is created in and running state. So yesterday what I did, kubectl exec -it. Then directly I gave this what is it, pod name. This is pod name. Okay, --/bin/bash. See what happened? It is telling default container is Nginx. It will take first container. So that is why it is taking default container and it is logged in. Okay. But how can I log in into the Tomcat container? Okay. So for that, just you need to add one more parameter here. That is -c. After that, you have to give the container name. What is the container name we have given here? Let me check quickly. So cat pod.yaml. If you see here, I have given two container names. This is the container. One container name is Nginx. Another container name is Tomcat container. Okay. Here itself it is showing both the things. Correct. So I'm going to give the container information or container name where exactly I need to log in. Okay. I want to log in inside the Tomcat container. So when I give this, so what it will do, it will take me directly into Tomcat container. Okay. If you don't give container information, randomly it will pick whichever you declared first one, it will pick first one. If you want to go on specific container, you can go also. So here I'm going and checking localhost, localhost 80, because in 80 port, what we have declared? We declared Nginx, correct? If you see in 80 port, we have declared Nginx. This is what I am trying to access from Tomcat container to here. Anyway, today we are going to discuss about networking, correct? During that time, we will discuss more about it. But just to remember that you can enter into specific container as well. Normally, this will help you whenever your pod is crashing, keep on, it is crashing. Even though if you create new pod, it is working fine in dev, but it is not working in staging. During that time, what you can do, you can log in and you can try to fix and you can try to watch what exactly happening. Even though from describe also we can take by using describe command. So kubectl describe, after that pod name, if you give, then it will give you the details. But if you want to log in into specific container and check, that also possible. Okay. So with this small update, I close this killer coda. If you want, you can utilize it. Okay. Now we'll move towards our, I will continue our workshop. Okay. So yesterday we have seen namespace, label. Okay, so I'll come from. So yesterday we have seen about architecture. After that, what are the objects we have? We have worked on, till now we have worked on only pod object, correct? Today we are going to work on replica set, deployment, namespace already we have done, service, volumes, secret, all these objects we are going to work. Okay. So we already discussed about pod. Pod is nothing but it will contain, it will help, it will keep container and it will run. Okay. After that, some basic comments we have seen. Then multi-container also just now we discussed. After that, namespace. Namespace, as I said, by default it will be whatever we are doing, that will come under by default namespace only. If you want to create any other namespace, you can create it. Anyway, you may have some doubts on namespace while completing today's class. That will be cleared. Okay. Next, see this namespace related informations or comments. So yesterday we seen label. Okay. So label actually, as I said, it will help you to filter, or it will help you to fetch the pods. Sorry, pods which is available inside the worker node and worker node 2. Okay. Why? Because whenever you are running command, it will not give you worker 1 pod, worker 2 pod and all. It will directly give both the pods. For example, if you want to give kubectl get all, then it will give you the all pods. If you want to filter from that, then we will use label. Label is not only using for this. Even though if you want to do any action, for example, if you want to delete or if you want to run some services only on that particular pod, during that time we will use we will use labels. That we are going to see when we will discuss about services. Okay. Okay. This yesterday we have done. After that, selector. There is small difference between labels and selector. What is the difference between labels and selector? See, labels are only, this is Unix only equality based. Equality based in the sense equal to or not equal to. Okay, but here when you use selector, you can use some more option like in, not in, or exist. What is mean by this? For example, I have a variable, sorry, label. I have a label called department. Okay, same. I have a label called environment. If you see here, I have label called environment. I have label called app and label called name. Three labels I have. Correct. So I can select if wherever environment equal to dev. Okay, if dev is available, then please show me. If dev is not available, then don't show me. That is what the equality base. But here in the dependency, we can tell them that it should be available. It should be available. Sorry, my label should be any one of these, whether it is ITSM, platform, or DevOps, which means if we will take this one environment. Okay, environment is dev. For this pod, environment is dev. For this pod, environment is prod. Okay, if I tell give me parts which label environment is dev or prod, anyone, if any one value match, please give me. Same like we have here apps nginx, tomcat, app monitoring, three we have. Correct. If I want to access, if I want to filter, give me a part which has app equal to nginx or monitoring. So during that time, what it will do, it will select first one and the third one. Why? Because it is matching that matching the labels. So it will give you these two parts like that. This is what the set base. Same like name not in also you can use. Okay, I have already given some example here in the commands. How can you how can we run these commands? So normally what happened, we will give kubectl get parts uh, -l. If we give -l, then it is nothing but we are going to filter based on the labels. So name equal to qa, not equal to qa. If you give equal to qa, then it will give you these two parts. Not equal to qa, then it will give you this part. Okay, we'll create all these three and we will see. From here, I have already set up. Just now I finished my EKS cluster before starting this class. Yesterday's cluster I deleted. So what I do, I'll create some files here. Okay, here itself, no issues. So my file is so something selectors, correct? Just I will say cell1.yaml. This file name you can give anything. It is not necessary you have to give cell, or you have to give depth, or you have to give service and all. Okay, you could give whatever you want. So I have created here one part. I'll create one more thing, cell2.yaml. So here I'll give this one. I just creating a file. I have not created pod yet. So selector3.yaml. So I have three different YAML. You may ask, why can't we run same YAML three times? No, why? Because if you run same YAML three times, already this name is exist, this container name is exist, so it will give you an error. So we have to use different pods, pod name, please. Okay, so this is my third one. Correct. So I'm going to install all these three. kubectl apply -f. See, you can give three files at a time. That is not an issue. Cell1, cell2.yaml, cell3.yaml. It is not accepting. Huh? Okay, then 3. Okay, so hello, are you able to hear me? Anyone please confirm?
Yes.
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 Okay, good. Okay, so if you see kubectl get pods, as I said, for pods you can give PO, just a PO, that is not an issue. So here I have created 3 pods for demo 1, demo 2. Now I'm going to use a selector. So kubectl get pods -l. Okay. So if you give only get pods, what it will give? It will give all the 3 pods, correct? Here I'm going to use -l, something environment equal to QA. Just I'm giving. Check environment is there. env QA, capital letter QA is not there. Okay. So env dev. So just I'm filtering. So env dev. Why it is giving only demo and demo 1? Why? Because this is matching with, this label is matching with demo. Okay, there is demo, this one environment is dev, demo 1 is matching with environment 2, but this is not matching. Why? Because this environment is prod. Okay, now I will go and check with the name equal to test. So only this part should show me, that is demo 2. Okay, let us check. So name equal to test, capital letter, small letter. Okay, capital letter only. Good. So if you select, if you give this, so that you will get this. Same like you can use not equal to also. So wherever name equal to not equal to is, it is there, then you select. So wherever you have a test, name equal to test, it will skip and give rest of the parts. Okay. Same like you can go with the set base search also. See, like, see here, I'm telling kubectl get L, environment, in the environment, whether the environment value is prod or dev. If anyone match no, then it should give. That is what my command here. So let me check with that. kubectl get pods -l. So here I'm giving environment is equal to anyone. So dev or else prod. So prod or prod. Environment equal to dev or prod. In I missed up. Equal to, not equal to, because this is not this one. Yes. Only dev, then it will give only dev. Okay. So same like I'll give one more example and we'll move forward. What example will give? We can give. So we can give this one name. Okay. Name test and QA, both it will come out different where it is coming. App. Okay. Wherever app is equal to Tomcat or Nginx one. Okay. Give me those things, those parts. Okay. Nginx one or Tomcat. So environment variable name is app. So what it will give? It will give to Nginx. I mean, I gave mistake in Nginx. Okay, so it will give to. Why? Because this will match here. So this is the major difference between labels and a selector, equality base and set base. Okay, like same like you can use not in, like how you use not equal to, correct, like that you can use not in. Okay. Now, next we have node selector as well. What is node selector? Node selector is nothing but, as Ravi said yesterday, whenever you create any pod, any new pod, so what will happen? Your controller will decide where I need to deploy this pod. Sorry, scheduler. Your scheduler will decide where I need to deploy, whether on worker node 1 and worker node 2. And your kind information in for this workshop we have taken only 2 worker nodes, correct? But in the office sectors and all, it is not the case. In IT sectors and all, it is not the case. It will be more than 1 worker node and more than 1 master nodes also will be there. Okay, different cluster also will be there. Inside one cluster, 2-3 master nodes also will be there due to workload. But if you know this setup, no, then easily you can handle multi-cluster as well as multi-nodes. Multi-nodes, no problem. Whatever you are getting nodes, the same node only. Instead of 2, in your office, you may see 5 nodes, 8 nodes, 10 nodes, like that. That's it. Okay. So whenever creating any pod, your scheduler will decide where I need to deploy based on the availability of it will check CPU, RAM, and storage, all those. Based on that, it will go and deploy. Now we can select by using node selector. We can select where my pod should get deployed, whether it is in worker node or worker node 1 or worker node 2. Okay, when this will help, well, what is the advantage of this? When it will help in the sense, say for example, we have around 10 worker nodes we have. In that one of the worker node, it is not working, or whenever we are trying to do some performance or something on that node, that we don't want to deploy anything on that particular node because of some issue, or we are checking, or we are doing something. Sometimes upgradation will do automatically. It will one by one node, it will remove and it will do that. But if you want to specifically avoid those nodes, during that time, what you can do, you can select this node selector. By using node selector, you can deploy where your node want to be stored, okay? Or where your not node, where your pod needs to be deployed and create containers. So for that, same commands, we are going to use same command, but here instead of this one pods, we are going to keep node. In the YAML file, if you see, we have given here app something like that, correct? So here I have to declare this node selector and the name equal to dev. What is mean by this? So even though if you take nodes also having labels. How can we check the labels? What are the labels set for this particular nodes, correct? So kubectl show labels. Kubectl get pods -- show labels. Okay, if you give this labels, okay. If you give this, what happened? You will get all the label information. For example, in demo, you have 3 labels: app equal to one environment, whatever we declare in our YAML file, all those information you will see. Why? Because YAML file, if you don't have YAML file, or it is not necessary each and every time you have to go and check what is the YAML file. Why? Because only one time if you create, after that if you delete YAML file also, your pod will run, correct? So during that time you can check by using this command, what are the labels tagged with my particular node. Same like you can check for nodes as well. See here, correct? So for nodes, these many labels have been attached. See, something we have cluster name, we have blah blah, many things we have in that. If you see something template version, see host name. So many labels by default it is attached. Okay, arc. Anyone have any question? Someone unmuted. Okay, no problem. So we have many, see here OS. Okay, so many labels attached. Who created this label? It is created by cluster itself. We have not created anything. It is created by default. It will create that by cluster. So you can use these labels also if you want, or if you want to create your own label, that also possible. You can create your own labels. Okay, so if you want to create your own label, you have to use kubectl label nodes, then node name, then you can give whatever you want. Okay, here we are not using control plane, we are using node name we are using. So let me copy and paste. Before that, see kubectl get nodes. Okay. So if you see here, we have these two nodes. Okay. Now I'm going to change this control pane to this node. Okay. Name equal to dev. I'm going to attach kubectl label nodes. Done. Now what I'm going to do, I'm going to say nodes show label. So it is showing labels for both. One is this one. We added for 24, 25, correct? This is the 24, 25. If you come here in the last, here, name equal to dev. See, name equal to dev has been attached. Okay, like that you can add your labels into pod as well as you can add your label into node. Once you add your label, then whenever you are creating your pod, that time you come here in the last, you have to give this information, node selector, and where you need to how can I select my node, how can I select node for you. Okay, so you are telling that select me node where name equal to dev is tag. Okay, if you give this, what happen, it will go on the create only on that particular node. Okay, so this is how we can use node selector also. So these are the basics of Kubernetes. I supposed to finish all those things yesterday, but we continue till today. So half an hour we extended, no problem. Now we are going to enter into the mid of Kubernetes now. This is the main Kubernetes agenda.
Your voice is breaking.
Is it?
Hello?
No? No?
Now it is clear, but what you said just now, I was not able to hear it.
Okay, I'll tell you again. See, whatever we have seen now, till now, node selector, these are the basics of Kubernetes. Okay, and whatever we are going to see after this, that is very much important. Those each and everything you are going to use, you are going to work on your environments. Okay. Now, I have a question, or you may have yesterday also. Some people are asked when we are using Docker, we deployed Nginx, correct? Why can't we deploy multiple images? Why? Because by using one image, we can create multiple pods, multiple containers, correct? In Docker, there is no pod, okay? Only Kubernetes pod concept is there. In Docker, why can't we create multiple container? Yes, we can create it, but the problem is managing the container is that is very challenging. Same thing here also. Now, till now, same thing here also. When I create pod, if I need 10 pods, what I need to do? I have to create each and every time I have to create. And second thing, when you are creating inside this, see, this one is actually this layer is which I selected. This layer is namespace. So whenever you are creating, this is default namespace. Inside the default namespace, only pod will create, correct? So why can't we create multiple pods here? But yes, we can create again. But the problem is the pod names will be always, it will be changed. You cannot use same name, same kind of pod. You cannot change. You cannot create. At least you have to change pod name. Then only you create multiple pods here. Otherwise, what happen if you create with the same name? What will happen? It will give you an error that already this pod is existing. Correct? So I'm going to create any one of the pod. Okay. So already I have 3 pods, correct? I'm going to create one more pod. kubectl apply or create -f cell1.yaml. So what it is telling, the selector demo is already exist, correct? So if I want to create one more pod, then I have to change the name. This name is there, correct? Inside the YAML file, I have to change. Again, we are hitting into the same problem which we are discussing about Docker, correct? To overcome this issue, and one more thing, each and every pod will get an IP address. Containers will not get any IP address. There is no IP address for container. This is very, very, very much important. Containers do not have any IP address and all. Container will work only on port. Okay. We have just now installed multi-container. When we did multi-container, what we did, localhost :8080. We used 80 means by using the port only, in between two ports, it will be connected. If C1 want to talk with C2, then it will connect with the port, not via IP address. Why? Because your container will not have any IP address at all in Kubernetes. So each and every ports will get an IP address. Each and every ports will get an IP address. Okay. Now, so to overcome this issue, we cannot create same type of pods, correct? We cannot create same type of same in the same name. We cannot create it. So to overcome this issue, we have a concept called replication controller. Okay, replication controller. After that, they introduced replica set. Replication controller is replica set is nothing but it is advanced version of replication controller. What is the difference between these two? It is very simple. Just now we saw labels and selectors, correct? So in replication controller, you can use only a label, which means if you want to use any labels inside the replication controller, equal to or not equal to only you can use it. In replica set, you can use set base also. Okay, not only not set base, equality base as well as set base, correct? Equality base and set base, both you can use it. That is why directly I jump into replica set. Okay, replica set and replication control, nothing, just if you want to change the name, that's it. I'll show that also. So now we'll enter into replica set. As I said yesterday, we are going to add layer by layer, layer by layer, layer by layer. Finally, we make our product security based as well as flexibility, reliability, all those things, correct? So this is one of the core future of Kubernetes, this replica set. By using this replica set, what you can do, you can create same name. You can create a pods on same name, like in a family. So they have 4 children. So if anyone come and hit him, boom, to replica set or any one of the pod, so replica set will take control, and it will pass your whatever you are giving the traffic coming from outside, no? So it will pass whoever available. So for this Nginx, port number 80, this Nginx also port number 80. For all the Nginx, port numbers are same, container names are same, and pod names also same. It is something like Xerox copy of 1. So 4 Xerox copy we have. And second beauty of replica set is, if any pod goes down, replica set automatically create one more pod. That is the beauty. So previously what happened here, one pod goes down, then you have to go there manually and you have to create it. Correct? Your Kubernetes automatically will not create any pod if it goes down. But here in replica set, it will create replica set's responsibility. This is nothing but one of the object. Okay, so replica set object's responsibility to create any one if any pods goes down automatically. Okay, but here what happened, if any pod goes down, it will give the information to API server. API server will give information to scheduler, but scheduler will not automatically start it. Okay, we have to check, we have to start it manually. Okay, so now I'll move to next slide. After that, if you have any doubt, please ask me regarding replica set. Okay, I gave one example. When we started with this architecture, during the time I clearly said that inside /etc etcd inside /etcd, it will contain your desired state. Desired state in the sense how many pods you want to be run for your service, correct? So that is what the desired state which is stored in etc. And second, what you have, current state or active state. So in current state, information will be given by kubelet. Kubelet will collect this information, it will give you the API server. And what controllers will do, it will compare. If it both are same, it will not do anything. If it find any mismatch, then it will tell to scheduler. So scheduler, it will tell to actually API server. Then API server see, is this normal path or it is coming under replication set? If it is coming under replica set, then what API server will do? It will instruct scheduler, hey, this is not normal pod. This pod is coming under replication set. So it is our responsibility to go and create one more. Then scheduler, what it will do? It will go and create one more pod. Okay. So that is what I explained here in my 2-3 diagrams. See here, this is nothing but your API server or controller, whatever you want in master end. Okay, master end, it will keep your desired state. Okay, in the node, worker node, you will have current state. Say for example, in the current state, we have declared that I need a replica set, okay, with 2 pods. I declared and I created. After that, what happened? After some time, 1 pod goes down. The moment when 1 pod goes down, your current state will become 1 and desired state already it is 2, correct? So your API server and controller and scheduler all will be work together and they will create a new pod. And they will equalize this desired state and current state. Okay. Do you have any doubt in replications? Okay.
So it will be created in how much minutes? Like new pods will be created in how much time?
Okay, it will create in few seconds. Okay. Again, it is depends on your resources, but it will not take like half an hour or 10 minutes, 5 minutes, even though 1 minute also it will not take. It will take within a second it will create. Even though we were not able to watch here sometimes in EKS cluster, when the moment it is deleting, now quickly it will start. Anyway, we will see that in practical, okay? Okay, now we will create this replica set. So this is the, what is it? Yeah, YAML file. So if you want any information, go to kubernetes.io and there you just go and search with here. For example, replica set. See, replica set, it will come. They itself, they will give all the examples, how the YAML file and looks like, all those things. You can take from there and you can modify, okay? Or else we have many platform that you can take it. Right? It's not going. Okay. Okay. So see here, replica set, kind is replica set. Till yesterday or till before discussing this concept, we used kind is pod, correct? That is normal pod. This is something like Docker. We don't need Kubernetes to create a pods and all, correct? But here we have kind is replica set. Then why we have a pod like that? We don't ask why, because if anything, if you want to run a single pod, during that time you can use that object. Anyway, okay, kind is replica set. Inside the metadata, you know that, see, 4 points are very much important in your YAML file. One is API version, kind, metadata, and spec. Okay, so inside the metadata, you can declare name as well as label. If you don't want this label, don't declare it. If you want to change this label, yes, you can change it, no problem. This is the name of this replica set. What is that name? This is the name of replica set. You can we create multiple replica set? Yes, you can create it. But again, not in the same name. Like how in the how we created pod with different names, correct? Demo 1, demo 2. Like that here, replica set also you can create multiple, but not with the same name. Okay. Then labels, if you want, you can give, or else you don't give, but you have to give the labels. As I said yesterday, if you give label, then only we can filter and we can do any action based on that labels. Next, inside the specification, see some new things we are seeing with compared to pod. Here, first they declared replica 3. What is mean by this? It is telling that we are telling that I need a replica set. Inside that, 3 pods need to be deployed. All the 3 pods same. Okay. So pod information here they have given container. Correct. This is the container. Container name is PHP radius and image they have to take from here, like how so you can take from this registry, and this is the pod. So this is the container name. So this setup, how many setups we need? We need 3 containers. 3 containers, 3 pod. So each and every pod, this one container will be deployed. And what is this label? Match label. Match label is nothing but we are telling. So whoever have whichever pod has tire is front end, those are belongs to our family. We also have some family names, correct? Something we have Tirupati or some like that, many family names we have, correct? Like that here also, it is telling that wherever you see tire equal to front end, then those are belongs to us. That is what, that is how they will come to know whether 4 members are there or not. Sorry, whether 3 members are alive or not. Okay, one is die. Okay, send signal to API server, like that. Next, what is this label? This label is nothing but whenever you are creating new containers, correct? Whenever creating container, during that time, please attach this label. That is what we are telling here. One is for checking purpose. Another one is whenever creating new pod, please attach this label. For example, whenever in a family, any children born, you will attach your family name, correct? After that name, we will attach our family name. Like that, that is what we are telling here. So whenever you are creating container, any new container, tomorrow, yeah, out of 3, 2 parts died, or 2 parts gone. So what replica set will do? Replica set will create another 2 parts, correct? So while creating new parts, you attach this label. That is what the definition here. So now I take this. I'm using yesterday whatever we have deployed, correct? We have pushed our image inside the Ravi, inside the dev pipeline, that is my repository, in registry login, Docker Hub login, and Ravi is my repository name. Inside that, I'm going to use version 1. Yesterday we created version 1, version 2, version 4, I think, if I'm correct. Version 1, version 2, version 4 we created. From that version 1 image I'm going to download. Here I give environment my dev. Okay, here also I gave one my dev. Here also I give dev. Here added one more, I added, but we don't want to give 2. If you want, we can give. But normally in organization, they will keep not only 2, sometimes they will keep 4 labels also. One is for environment, one is for application, one is for something like dev or database or application, like that. They are to divide the pods or to divide the replication set. They can keep multiple labels. Okay. So now we will create this replica set, and we will test whether it is working fine or not. So vi, I'll create here rep.yaml. Again, I said this name is not, you have to give rep on, like, not like that. You can give whatever you want. Okay. So I've given, I said that replica set is 2. Okay. I'll make it 4. So I need 4. No, kubectl apply. So my pod has been created. Now I'll go and check kubectl get pods. So when you see kubectl get pods, you are seeing multiple pods, but we created only 4, correct? Why? Because already we created these 3 parts. See, selector, demo, the selector. So these parts, it will start with nginx-rs. What is this? From where it is taking that rs? It is taking the name. This name it will take, and for these parts, it will give you random number. It will not give any other names and all. Why? Because previously for pod we given name, correct? Here in the kind we declared pod and we give a name so that it was taking pod, nginx pod, ravi pod, like that. But now what happened? We are giving the name for replication set, so it will take replication set and uh, any random number for pod. Now we'll come to that question which someone asked, that if the pod is deleted, how long will it take to recreate, correct? We will delete one of the pod and we will recreate. Before that, to avoid confusions, I'll remove these 3 pods, okay? So remove this kubectl, delete pod. Okay, so 3 parts we deleted. We have only 4 parts currently running. Okay, to understand more, we will take some more details. No, why? Okay, so it will give you the information about IP addresses. Okay, and you can see this totally 4 part. One part deployed on 237, another part 25, another part to 237, 25. So 2 parts deployed on worker node 1 and 2 parts deployed on worker node 2. Okay, who will take care of this? Scheduler. Okay, if you want to deploy all your pod in only on 237, what you need to use? You can use node selector. Okay, now we will delete one part. Okay, I'll take this part. See the pod name. Okay, kubectl delete. 1 minute. Increase the. Okay, so kubectl delete pod. Which part I'm going to delete? This part. So see that name 658GP. This is the part, and IP address is 210. Okay, what I'm going to do? I'm going to delete this part simply. After just I'm opening. See here. Someone asked, no, how long it will take? Within 3 seconds we checked. I don't know. It might created in 1 second also, but we checked within 3 seconds that pod has created. Within 3 seconds it's created, and this is important. It changed the name. Okay, it changed 84 RJS. Rest of the 70 is there, and MG is there, and Z also is there. Only 658 gone, and 84 RSJ came. So this is my new pod, and it is created 3 seconds before. This also one of the important point. What is that? See, whenever your pod is recreating, no, during that time your IP address will change. See, for 658, IP address was 210, but here, if you see, IP address also changed. So whenever your pod recreate, it will change the IP address. It will not keep your old IP address. It will not, if that is not your old pod at all. Completely it will remove and it will create it. Okay. You may ask, inside the pod, if anything running, how can we take backup, all those things, correct? So that will be completely whenever they are running. If they want anything, if they want to take backup, for that they will run some other pod, and that is different scenario actually. Taking the backup all the pods is not possible, but they can running via containers. Containers is the main agenda. Whatever they want to do, any changes or any new version, then they will create container and they will update the container. That also we are going to see in today's class. Okay, now replication set. By using replication set, we got this feature. Okay, here also we have one drawback. What is drawback? In the sense, see, whenever we create any new pod, I want to upgrade anything. say for example, I want to change version 1 to version 4. Okay, I want to change this image. So vi replica, just I want to change this image to version 4. Version 4 is there or not? Okay. So kubectl apply -f rep.yaml. So what it is telling? It is telling configure, correct? It is telling configure, but actually what happened? It did not configure. Configure in the sense, whenever you are do any changes, your pods will kill and it will recreate. If you see here, no pods has been recreated. If you want more information, in version 4, what was our output? The output should be something like the output is this, Docker container should work via Docker file, something like this. This is what the output, correct? We will see whether this output is giving by this container or not. I'll log in into any one of the container. Okay. So kubectl exec-it. This is my container name. /bin/bash. Sorry, this is what my pod name, not container name. Okay, I'm inside this container. Okay, see here 72ZM. I'm inside this container. I'm going to run localhost. Sorry, call localhost :80. So what it is coming? Docker container is coming. This is our version version 1. Okay, inside the version 1 we kept a Docker container. In version 4 we kept a Docker file, something like that. That also we'll check now. What I will do, I'll delete this replication set. Okay, kubectl delete -f rs. Sorry, rep.yaml. So while deleting, you no need to go and delete each and every part separately. If you delete this rs replica set, all the parts will be go down. Now I'll go and check parts. There is no part. Now what I will do, I will go and edit. Sorry, already I edited, correct? Version 4. Now I'll go and create. Instead of delete, I did not change anything. Create -o void. Okay, container is creating. I think 4 is not there, it seems. Let me check whether 4 is there inside the Ravi folder. So Docker Hub inside the Ravi folder. Tags. We have 4. Okay, actually here a tag name has been changed. So we will use version 2. I did something yesterday while checking. Okay, we'll go and do anyway. That also one of the proof that version 4 was not updated. Why? Because if it is updated, all our pod will goes down, correct? When we applied the changes. So now I'm create. So I'll go and check the pod status. It is running now. I'll enter into any one of the pod. kubectl exec-it. So this pod name. Okay. If you want to enter into any one container, then you have to use -c then container name. But we don't want to give here because only one container we have per pod. So we no need to give that. Okay, --/bin/bash. I logged in. I just run local host. All I need to add. So I need to use localhost 80. So it should work with Docker. Before what it was come. Okay, same thing. Both the things we have same, but no problem. So we have tried with different version. What is the drawback of this replication set? If you create, if you want to do any changes, if you want to do any changes in your replication set, you have to completely delete it. Then only you can create. In the live, you cannot do those changes. Okay. Till now, do you have any question again regarding replica set?
Is there any way to overcome this drawback?
Yes, it is there. That is what layer by layer will go. So this is the drawback. To overcome this drawback, we have deployments. What is deployments will do? Deployment is nothing. It will work on top of this deployment. Replica set. It is one of the layer of replica set. Okay. By using this deployment, what you can do updates and rollback. Both you can do. Yesterday, someone asked if anything we did wrong, how can we roll back? Is this possible in Kubernetes? Yes, it is possible. Okay. By using Kubernetes command, it is possible. So these deployments we are using to overcome this issue. Okay. How in the sense, if you see, this is the deployment file. Instead of what is that? Instead of replica set, just I updated deployment. That's it. The rest of the things are same. Whatever we have done here, whatever we did here, the same only. If you want, you can compare. I'll copy here. I'll copy. Why I given 3, I will tell you. Okay. So I keep here. See the difference? App 1, app 1. Here replica set kind is replica set. Here deployment. Metadata same. I just changed the name. Why? Because deployment I gave a dep to understand it. If you give RS also no problem, but that is not right naming convention. You give a dep. So after that same labels and replica also I'm using same under the specification and selectors also same. Templates also same. And finally containers also same. Just I given deployment. That's it. Instead of replica set, I gave deployment. So by using this, what this deployment will do, this deployment actually it will create this deployment will create replica set only, but extra 2 jobs it will take care. One is updates, another one is rollback. Rollback, if anything you did wrong, if you want to go to your previous version, you can use rollbacks. Okay. Updates, how updates will happen, I'm going to show now. Okay. Now I have here, if you see version 1 and version 2. Version 4 is not working due to some, this one I don't know, we will see that later. But version 1 and version 2, if you want, we can use the direct Nginx also, okay, for testing purpose. Okay, so version 1 and version 2. Now what I'm going to do, I'm going to create this deployment. Before that, I'll remove all the existing pods. So kubectl, delete -m -f rep.yaml. Okay. So we don't have anything. kubectl get all. Okay. Okay. kubectl get. I don't have anything. This is normally created by Kubernetes service. It is not created by us. Whenever you freshly log in and you check this, at least minimum 1 cluster IP will be assigned and services will be there. Okay. This is for communicate the components each other. Okay. Now we have removed everything. I'm going to create one file called deploy. Something deploy 1.1, because you should not confuse in future. You have to give only deploy, then only it will work like that. Okay. So I'm going to paste it. Now we'll see kubectl kubectl create -f deploy 1.1.yaml. When you do kubectl get all, just I'm giving all will give you the all informations. Okay. So what it has done, whenever it is running, it was created 1, 2, 3, 4, 5 pods. 5 pods it was created, and this is common service. This normally by default service. See here, it is created deployment. Totally we given 5. Out of 5, 5 is ready. Okay. This is available. This is up to date, and when it is created 6 seconds ago. And if you see here, replica set also created. We thought deployment is different, replica set is different, correct? No. Deployment is nothing but replica set only. On top of it, it will give you one more layer to upgrade, to update and roll back. That's it. Two things deployment will do. No. In short, we can say deployment will keep your version controlling, it will keep, like how we have version 1 image, version 2 image, like that, correct? So each and every deployment, it will keep one, what is that, version it will keep. To check that, kubectl rollout history, rollout history, deployment and deployment name. Deployment. For deployment, you can give deploy short form. Okay. And what is the deployment name? Nginx dep. This is the deployment. So when you give rollout history, see here, one revision. What is that one revision? This has been, this whatever you applied here, correct? kubectl create deploy 1.1.yaml. When you apply, it will take one revision is 1, which means nothing but your image, how you are taking version 1, version 2, correct? Here we are calling is revision. Revision is 1. Now what I'm going to do, I'm going to update. I'm not going to create new one. In replica set, what we need to do, we have to delete completely and we have to recreate it if you want to do any changes. But here, I'm not going to do, I'm not going to recreate, just I'm going to update. So I update my image. Now, I'll go and apply. See, first time you have to use create. Second time, when you are updating, you have to use apply. That is why normally I will use apply for creating also. But it's not an issue. First time, if you, while creating new YAML file, during the time, if you use apply, it will not do anything. It will create it. Okay. So I'm going to create. See, deployment configure. This error message, we can ignore it. So if I give all, if I give get all, okay. See here, this is the very interesting part. Your replica set is 2 replica set created. One is before, one more time I'll give you, so that what happened previously, what was the replica set was there? This was the replica set. Yeah. 4B9. This is what your replica set. First time when we created revision 1, correct? Before revision 1, 4B9. This is what the replica set created. But now when I upgrade, see here what happened. 4B9, it is old replica set. Then it was created 946. After that, it moved all the pod from here to here. This is what the job done by deployment. What deployment will do? Whenever there is an upgrade in YAML file, it will create new replica set and it will smoothly convert whatever pods are available here inside this replica set. It will smoothly convert to here without any disturbance, without any impact to the customers. It will smoothly remove from here to there. And this changes is there, whatever we have done, that changes it will keep as a version 2, revision 2 here. Okay. See, again I'm going and checking revision 2. If you want to roll back, no, I don't want, I want to go back in the sense, you can roll back by using kubectl rollout. After that here, you can use this command, undo deployment nginx, which revision you want, where you want to jump. You want to jump second, this is what the second. If you want to jump first one, yes. If you jump first one, what will happen? Your image will be version 1. Anyway, we will see this rollback alone when we after we done Ingress. Why? Because in Ingress, what we can do, we can see different images here. Okay. So any doubts on deployments and rollbacks? So that is what I mentioned here. See here, RS version 1 first it will create, and second, when it is create RS version 2, correct, replica set, RS is replica set. When deployment create replica set 2, it will take as a revision, and it will just delete it in the sense it will unresponsive. It will go to unresponsive mode. This will be become active. Then again, if you do any update, then it will take version 3, that is revision 3. So if you want to roll back, then it will roll back. And here I gave one important notes here. Okay. I mentioned there. Okay. Here, one thing we need to note that whenever you are rollback, correct? Whenever you are rolling back, whatever the configuration inside the YAML file, that will be changed. For example, here we were using version 2. Here we were using version 1 means it will roll back from version 2 to version 1, but it will not roll back your pod counts. When you are creating a new version, during that time you may increase the pod or decrease the pod, correct? So when you are moving back, it will not consider pod count and all. Whatever pod count in the last version was there, that only it will maintain, but only configuration it will change. But because in interview they may ask these types of questions. See, when we are roll out during that time, for example, in my version 2, I declared that I need 2 pods. In version 3, I declared that 3 pods. So after rollout to version 2, how many pods will be available? Like that and all, they may ask. So you just keep it in mind. There is no changes on pod. Whatever in the last current setup, whatever pods are there, those pod only continue. Only the configurations, those will change. Yeah, go ahead if you have any doubt. Okay, as I said, whenever your replication set newly created, it will delete your pod and it will recreate. That also very much important. It will not move from here to here. The pods will be deleted. Why? Because anyway you are going to change the name, image, correct? If you are changing image, definitely it should delete and it should recreate. While recreating, it should download a new image from your repository and it should create. But when you are rolled back, your replication set ID, one replication set to have one ID, correct? Those ID will be remain same. Okay, just it will go to unresponsive mode, but that ID will be remain same. Whenever you are jumping into version 3 to version 1, then replica set ID will be change in the sense it will not create new replica set. It will maintain the old replica set itself. Just it will make from deactivate to activate. But by using this and all, we are not going to do anything, just for information. Okay, so these 2 revisions we have seen. One version 1, version 2. If you want to do some changes here, so we can check that also as a version 3. 1 minute, we will complete this also.
So is there any common challenge we have for deployment?
Deployment, yes, we have challenge. What is the challenge? The same kind of deployments, if you want to deploy on production, or if you want to deploy on
So is
pre-prod.
there any downtime? Because when you are doing right, when you are moving that configuration, right, replica shift from V3 replica 3 deployment 3 to deploy existing versions, is there any downtime?
No need any downtime.
There is no downtime.
No downtime. Smoothly it will. That is what I said. Smoothly it will transfer from this to here. It will not transfer all the pods in what at a time. It will transfer one by one, one by one, one by one, like that. Whenever you are doing upgrade from version 2 to version 3, during that time also it will transfer slowly one by one. Okay. Same like when you are doing rollback, during that time also the pods will be slowly, it will roll back one by one, so that you will not feel the this one impact.
Is there any case something when you are doing the rollback? Is there any something deployment got failed, something like that?
While rollback, deployment will not get failed. Why? Because see, when you are creating new, during that time may get failed due to, for example, just now we seen version 4. When we keep version 4 image is not working properly. Due to that we are getting some loopback error we were getting, correct? Replication set will create, but your images or your container will not start. So that is why we assume and we roll back. For example, we are going to roll back in the sense, but already version 2 was working fine. That we sure, correct? Because it was working till today. After I deployed a new version, it is not working, which means our previous version, it should work.
Okay.
Yeah. Next, we'll go to important topic. It is also one of the important topics, networking. It is very, very much important in Kubernetes. See, by default, as I said, inside the pod, if you have multiple containers, this is not recommended, but just I'm giving you the heads up. So whenever we have multiple containers inside the pod, so if you want to communicate from one pod to another pod, one pod to another pod, it should communicate via port only. Why? Because these pods don't have any IP address. Local address 80. 80 means, say for example, this one, Nginx, I exposed in 80. Okay. Same like for Tomcat, I exposed in 8080. Assume. So what happening whenever you are giving local host from here or here, wherever, whenever you are giving local host, it will come and hit Nginx, this container. Whenever they are using local host 8080, it will come and hit Tomcat. It is very simple. It is within a pod. Outside the pod, no one can access this. It is something like they are sitting inside the jail. Only both the colleagues can, both the people can speak who are inside the jail, but from outside, no one can do anything. Okay. So by default, inside the container, this is what the container level networking. There is no network and all inside the container. Only port based communication only it will be there. Okay. But if you see one pod to another pod, if you come to one pod to another pod, say for example, in one pod, I have one container, another pod, I have one container. In this pod, I have Tomcat, another pod, I have Nginx. So during that time, they can speak via IP addresses. Why? Because as I said, each and every pod will have its own IP address. Even if you go and check here, our deployments get pods -o void. If you give, see here, each and every pod will have its own IP address. Okay, but each and every container will not. So how can we communicate from pod to pod? If one pod want to communicate with another, then you can use this IP address. Okay, if this pod inside the Tomcat, whatever I have, if this pod want to communicate with Nginx, then you can take Nginx IP address, that is internal IP address, to take it and give the 80, then the port number. Then what it will do, this IP address will take you till here. 80 port will take you till here. Okay, then you will get the reply. So part to part communication we can do via internal IP address. But here
Can
we
you
have
please
one challenge.
networking?
Okay, networking in this. Okay, inside the pod, if we have multiple container, both the container will speak via port number only. Okay, why? Because for container there is no IP address assigned. IP address assignment will only happen for pod, not for container. Okay, if you want to make communication between two pods, then for example Tomcat, this pod, okay, where we have Tomcat, correct? This pod want to hit Nginx. During that time, what it should do, this pod should take this Nginx pod IP address 192.168.1.8, then port which we exposed Nginx, correct? That port. So what this IP address will do, this call 192.168.1.8.880, you are hitting from here. When you are hitting from here, it will take here, this IP address will take here till the pod, and this port number 80 is there, it will take you inside the container. This is how the communication will happen between pod to
Here, because
no.
to create a Docker network, right?
Correct. So no need here. By default, this is what the networking, but here we have disadvantage also that we will speak. But by default, you no need to do anything. This is by default behavior of Docker, Kubernetes. Delete, no problem. It will create an active state. And the condition is whenever you are creating new pod, the IP address will be changed. Correct? So here, this guy is hitting now. Due to some reason, if this pod is goes down, next time also it will. If this guy is hitting with 108, it will not work. It will say no, unresponsive. Why? Because it is newly created and IP address also changed. For internal communication also, you cannot use this. Even though if you have IP address, for internal communication also you cannot use this. And who will assign these IP addresses? Who will, when it is creating, who will assign this IP addresses in the sense? When we see in our structure, architecture, there we have discussed about network proxy, correct? So this kube proxy or network proxy, this kube proxy will take care of all the assignments of IP address, all those things. Again, it will take the control from API server, but this will be the responsible to assign the IP address for all your pods. Okay, so we have seen the basic networking of Kubernetes. Okay, now we are moving towards advanced networking. So this is the drawback which we have, correct? So I will show you. I'll take one part and I will go there and we will try to do call. We'll see whether it is working fine or not. Okay. I'll take any one of the part. So this is the part, right? So I'll go into this part. So kubectl exec -it. So I'm going to this part. See, for deployment, it is started Nginx depot because we have given that name. Okay. And this 946 ID is nothing but this is replica set ID. And this one is pod ID. So when you are giving this full name, it will come to know this is the pod which is sitting inside this replica set, which replica set created by this particular deployment. Okay. Now, -bin/bash. I came inside the pod. What I will do, I will take any one of the IP address. First, I will run localhost, call localhost :80. So it is giving me the output. Why? Because it is internal. In this pod output itself, it is giving. I want to take this IP address and try to do call :80. So it is giving this 80 53 dot okay 53 79.53. Okay, see here I'm sitting 4 FBB. I'm sitting inside the 4 FBB. I'm trying to access this part 9BCF. Pod to pod communication, we can use the internal IP. That is what I said, internal IP. But see, this pod is each and every 5 minutes. Say, for example, we have some work. So we have written some script here inside this pod. Okay, every 5 minutes, go and check something in, go and check these details. Okay, what happened here? If this pod goes down, which pod? This second pod, if it goes down, 53 pod, if it goes down, or due to some corruption, if it is recreated, automatically IP address will change, correct? Then if it hits no, then it will give you some error, something error like this. So could not connect to the server, could not connect to the server, it will give. But backend pods will be run, but IP address has been changed. This is one of the drawback. We cannot use internally also. Internal purpose also we cannot use by default networking. So to overcome this issue, we have services. We have services. Services is nothing but it will add one more layer on top of your deployment. One more layer it will add top of your deployment. So what these services will do? So 3 types of service we have. One is cluster IP, another one is node port, another one is load balancer. 3 type of services we have. What these services will do? Say for example, we'll go towards node port, sorry, cluster IP. If you go to cluster IP, if you select cluster IP, what it will do? This service will create and it will create one virtual IP. I'll show here. So deployments you have. These both the deployments, you don't have any service. Assume this deployment you don't have any service. Okay, this is normal deployment. So this part want to communicate with here. Okay, so what it can do? It takes this IP address 0.10 and it will hit here 80. Whenever it is hitting, then it will get an output. Due to some reason, if this pod goes down, the automatically IP address will change, correct? But it does not know that the IP address has changed and what is the IP address, all the details this part don't know. It will keep on try with the old IP address only. If we write some script, automatically it will not do. If we instruct this pod to do like this, okay? So this drawback overcome by service. Whenever you are adding service, so this service type is called cluster IP. What is this service will do? It will create one virtual IP, and whenever whatever pods are available, those pods information it will collect. The service, what is the service job? It will collect these IP addresses and it will keep it in record. If tomorrow, if this pod goes down, another pod is come, then what it will do? It will take that IP address also here. No problem. So whoever coming from outside, okay, or this pod is coming, this pod want to speak with him, then it will not do call 192.168.0.20. Instead of, it will use virtual IP. What this virtual IP will do? It will, okay, you want to speak with another pod. Okay, what is the port number? Port number 80. Oh, port number 80, this is the guy. Go there. Say, for example, if we have multiple pods, what will happen? It will communicate via this VIP, whichever pod available. Why? Because multiple pod also having same port number 80, correct? So during that time, when you have multiple Xeroxes, during that time, what you will say? When you have multiple counters, what you will select? So whoever free, it will send to them, correct? But this time, it is not using the pod IP address. Instead, it is using one virtual common IP address. So that will provide by our service, and it is service responsibility. Whenever this pod goes down, whenever creating new, then those IP address it will bind with this VIP. That is virtual IP. Okay. For node-to-node communication, we are using cluster IP. Okay. So cluster IP, same concept what I said now. So whenever this node 2 pod want to connect with node 1 pod, okay, then they can speak via this VIP. See here, curl, if you give 10.10.10.2, then this pod can speak with it. We'll try this. Okay. We'll create one IP. Sorry, we'll create service and we will test whether it is working fine or not. Not node port, it is something called cluster IP. Cluster IP. I'll take this and I'll create this service. VI something called service. So here I'm inside the pod. Okay, VI service dot YAML. So I'm copying this service. I have a see here I have a port and target port. I'll explain you what is port and target port. So here port is nothing but income traffic. So whoever requesting, he can enter via port 8080 and the target port is 80, which means if node 2 want to hit node 1, it will go and enter the service via 8080. It will enter to service via 8080 and it will hit to the next pod or target pod via 80. That is target ports. Okay. Now what we'll do, we created YAML file. We'll create this kubectl. Before that, just I want to show you SVC. kubectl SVC. It is created by default cluster. Okay, we don't have any service. We have not created any service as of now. kubectl create -f service.m. So service has been created. Now I'll go and check service. See, new service has been created. Service name is Nginx depth, which we have given inside the kind. So third kind we are seeing. First kind pod, second kind we say, sorry, fourth kind. First kind pod, second kind was replication set, replica set. Third kind is deployment. Fourth kind now service. Okay. So service and I given the name Nginx deployment. That is why it is showing Nginx depth. And if you see here, I got one IP, that is cluster IP, correct? So going forward, what I can do, I can communicate this any one of the pod via this IP address. Okay. And one more important thing here. So my dev is there, correct? Environment selector. What is this will do? This particular service will apply only when pod have this label. Yesterday you might have confusion about why we are using labels like that. Okay, we have seen some example. This is also one of the advantage why we are using label. Okay, so if you see here in our whatever pods we have, kubectl get pods -f show labels kubectl
Get pod.
kubectl get pods -f show label. See here, in my each and every pod, I given environment equal to my dev. Correct? So whenever I create a service, this service will apply wherever my pod having environment equal to my dev. Okay, so this service will apply all the pods, correct? So now what I'm going to do, I'm going to call this IP address. What is the port? 80 I'm using. It is not accessing. I think it is because due to we have not allowed this one HTTP, but let me check whether I allowed or not. So because communicator yes. So we have to allow the traffic. This is AWS what is it restriction. Okay, normally each and every cloud will have these types of restrictions. So you have to go and manually you have to allow it. Okay. So I'll take any one of my worker node. So just I given name was CCD project. Go to security groups. The security groups for created by created for cluster. Okay, EKS cluster which we created. Okay, see there is no rule for outside traffic. I think that is the issue. Let us check. So it is coming from traffic. As I said, in your organization, you should not allow all traffic, and security breach will happen. Okay, here I exposed in 800. Let me check that. Exposed in 800. Okay. Actually, this server is, what is this server? This server is out of cluster, correct? This is not inside the cluster. This server is out of the cluster. So to communicate via cluster IP, your both the nodes should be there inside the cluster, correct? But whatever I'm using, this server is separate server. If you see my EC2 dashboard, there I used a separate server to access the CLIs, correct? From outside the world to access this, I created this server. So it will not work. It may work from these servers. For example, I'll take any one of these server, I'll connect it, and we will check here by using that IP. If we take this IP address, 8080. Because cluster IP will work only within a cluster, not outside of the cluster. See, why? Because we've exposed, we told to the cluster IP that you have to expose this on port number 8080. That is what I said, correct? So it will hit to port number 80. Whenever you're giving 80, it will hit to 80 and it will give you the result back. So why it was not working from here? Don't confuse. Why we are not able to accessing from here? Because this server, this particular server 172.31.45, this server is not part of our cluster. Okay, by using this cluster IP, you can communicate only within a cluster. My server is sitting somewhere here outside. That is what it was not working. But inside this node, you can access. This is one of the drawback of cluster IP. To overcome this drawback, we'll move towards node IP. But before that, do you have any doubt here till now in networking part? Okay. So advantage of cluster IP.
So if that is a disadvantage of cluster IP, so are we not going to use cluster IP, or like
Very good question.
we will not use combination of node port and cluster IP?
See, as when we are creating any application, for some application or some node, customer can hit, customer is sitting here, correct? Customer can directly hit from outside to this cluster. Say for example, facebook.com or your ICICI web.com, correct? Banking, web banking. Whenever customer is hitting, it will come and it will hit to their web server first, correct? And it will ask you username and password. That username and password will be stored into the database server. That database server sitting in some other node, correct? Why? Because inside the node, it is not necessary all the nodes should be Nginx. You can create 2 replica set or 2 deployments you can create, correct? So what happened? Whenever that request is coming, internally, wherever our nodes want to speak or our pods want to speak internally, there we will use this cluster IP service. Wherever customer interact from outside, in that place, we will use node port.
Okay.
Okay.
So all the internal communication on cluster IP and all the external communication on node port.
Yes.
Great.
But that is a very good question. Yeah. So now we will go on.
Basically, for backend service, we'll be using the cluster IP, correct?
Yeah, very good. Yes, internal communication.
For front end, we'll be using the node port.
Yes.
But we can expose that also, right? That cluster IP.
Which one? Cluster IP. This also we exposed only. Okay, we exposed, but internally we expose. Not out of the outside the
service also can, when service got created, right? That can be exposed, right? So that from outside of the network also people can access.
Actually, one of the service. See, totally 3 types of service we have. One is cluster IP, node port, load balancer. See, by using node port and load balancer from outside, the customers can come inside by using notepad and load balancer. But when you are using cluster IP service, it will not allow outside of the customers, but it will allow only inside. It will overcome the drawback, which whenever pod goes down, this IP address will change, correct? To overcome this drawback, we are using this cluster IP for internal communication.
Okay.
If this drawback is not there, if it is permanent IP address, even though if my pod goes down, that IP address will not change. In that case, we don't need this cluster IP at all.
Then deployment is enough.
Yes, deployment is enough.
Yeah, I understand that.
Yeah. Now we'll move towards node port service. What is this node port service? So whenever from outside the cluster, anyone want to speak with my pod or my node, we will create node port. So what this node port will do? Normally, this node port will create one port. Okay. Whenever customer, see now the customer whenever hit, he will not hit your internal IP. It will take, customer will take external IP. Okay. So this external IP hit by customer because customer coming from internet. So whenever it is coming to our cluster, if we have node port service, what it will say, customer should hit with port number. Okay. This IP address and which port he want to hit. Now directly he will not hit this port. Actually, we will give it to this port. Who will give to the customer? We will give. But here also we have
one question here. So now, suppose you want to add a DNS over here. So this IP should, whichever the public IP getting created, that public IP I should add in the DNS record.
No need as of now. But next, the node port also have drawback. Okay. To overcome this, during that time we will come towards DNS. Okay? That will be clear. Okay, now as of now, think that I take the IP address of external IP, I give it to customer. But if you come and hit via 80 port number, no, directly it will not work. It will not allow you. So what I'm going to do, I'm going to create service on top of this cluster. Okay, this time whenever I create this service, it will assign one, it will give me one port. It will assign one port for this particular service. This is static. Port number will not change. Okay, static. This IP address may change. This IP address may change. Okay, mainly we can say that here whenever pod is goes down, IP address is changing. Same like whenever node also goes down, also IP address will change. Correct? So if this node is goes down also, your node port, what it will do, whenever your IP address is coming here, whenever your public IP is hitting here, we already will give them service port, that is 30161. So they will come along with this port. They will, who will give to the customer? We only give. It is our responsibility. Because if you want to speak with me inside the pod, you have to come in this way. What is the way? You take any one of the public IP address, okay, and you come with this port. Whenever it is coming to our cluster will check, and cluster will check the 30161 port number. Cluster already knows that these guys has created node port service. So that node port service 30161, it will give the request to node port. Now node port receive the request via 30161, correct? What node port will do, it will forward that ports to your services. Via services, you will hit the final end. For example, if it is 80, then it will hit to 80. If you see here, 8080 is...
When we talk about this service, what is this service?
Sorry?
Here I'm okay that this is node pod, but what is this service here?
Which service?
Here we have node. Yeah, this is node port, but what is this service which is sending the traffic to the node?
Okay.
How, like, is it Ingress or what?
No, it is not Ingress. It is not Ingress. Actually, both are same only. This services will sit inside the node port only. Both are same. Just to explain, I kept both like this, because whenever the okay, I'll do one thing.
Yeah, it's kind of confusing me. Like if we talk about that.
No problem.
Because from node port, it is directly talking to node, that is like fine, but this confuses me.
Yeah. So whenever we are receiving IP address on 301 in the port node port service, what it will do, it will convert that service to 8080. Then this 80 from 8080 to it will send to your target port. So we have already told to our node port when we are creating this service, okay, when we are creating this service, if you get anything from cluster via 30106 to your 8080, those requests you send to target port 80.
Okay.
Okay, so I will do some modification here and I'll share you well.
And where do we define this 30161? Like there is a big range from 30,000 to something. So where do we define this port? Like, is it with the external URL which user will be accessing?
Correct. External URL, whenever you are opening and you are accessing from here, correct? In your browser, you can access. You have to give the port. Okay.
Like where actually that port is defined?
IP address colon port. For example, here you have port IP address 3.5.56.78. This is public IP address colon that port you need to go 3160, whatever port you have.
Yeah, that is what I'm saying, that where is that record saved for that this URL is having this IP and this port, where that record is saved.
Here we have given correct. See, when we are creating this service, we have clearly declared that wherever our pod have MyDev, this service will apply onto those pod. Okay, this is not separate service. The DNS concept itself we have not entered into that. Okay, we are going purely IP address. There is no DNS concept. Still, we have not entered into resolving concept. Okay, directly I have a IP address, external IP address of the node. We will give this to customer and we will tell them, boss, I have created a node port service. For that, this is the port number. If you want to speak with me, please come along with this port. Otherwise, my cluster will not allow.
Basically, when you deploy this service file with type node port, that time this node port will get assigned 30161, something like that.
Yes, correct. Whenever you are creating the service, see here, after creating this service, you will see this. See, node port 30161 will be assigned,
Okay.
but it will be assigned from cluster. Okay.
So
Basically,
that's a kind of random port number which get assigned.
Yes, random port number. But if you want, you can give a port number also.
Specify that
Yeah,
port
you can
number also.
specify
Okay.
also. But it will be like 30,000 to 38,000 something. Some range is there. 30 plus range is there. In between
Yeah.
only you will get allocated this port. Now
Got
we
it.
will do the practical session. So once we do that, so you will get some idea. So what I'm going to do, I'll let it run these pods. I'll just remove this service alone. I just remove this service. kubectl, delete. Service.yaml. Service.yaml. So what happened? This port is removed. Sorry, this SVC is removed. kubectl SVC BTCC. Okay, see that service removed. This cluster IP service got removed. Now we will create VI service node. Just a I'll copy this. Paste it here.
And like, don't we need both the services like node port as well as the cluster IP? Now you have deleted the cluster IP. How internal communication will happen?
No. You can do that, but here you have to change the name. Actually, we are not going in depth to communicate to make a communication between database and web applications. All those things. Definitely, in that case, they will create two services. They will create two services, and they keep the pod name is different. The label is different. For example, something like environment backend, front end, like that they will keep. So your cluster IP will apply only for backend. Your node port IP will apply only for front end, like that.
Okay.
Yeah. This is the one of labels. So kubectl create -f. We have service -node.yaml. Okay. So I'm going to create kubectl get svc. See now, it has given one random port 32180. Okay. Now,
can you assign some specific IP? Okay,
Yes.
delete that service, and again, can you deploy that?
it will change.
No. What I'm saying is, delete this service. Okay, again, and you assign with a specific port. It is possible. It is happening or not? Let me see.
Yes, it is possible. So let me show you. See here, you can specify target port. No, not this one, not this one. Sorry. See, you can specify the node port so that whenever you are creating your service, the same node port will come.
Okay.
So now this port has been assigned. Okay, we have to take a external IP address of our nodes. kubectl get nodes -o void. So this is what our external IP address. We'll take this external IP address here itself. Why? Because my server is out of country, correct? Out of the cluster, correct? So now I'll try from here itself first. Call this IP colon. Now I have to give the port number, this port number 32180. When you give, you are getting the output. Same, I'm trying to access from my laptop.
You can access from browser also.
That is what browser. So when I go to my browser, (180), see, it should work with Docker. So after creating this replication set, deployment, service, all those things, first time we are accessing, we are hitting our pods from outside. Okay, but the rule is you have to take any one of the node. It is not necessary you have to take this one, even though if you go with 65, no, it will work. See, Control C.
So in which scenario somewhere we need to expose with the public IP so that you can access from outside? So in the same scenario?
Yes, in the same scenario, this node port have drawback that each and every time we cannot give a public address to the customer, correct? If instead of typing facebook.com, if you give the IP address and give the port, can we remember? No, correct? So that drawback we have in node port. Okay, but by using this IP address, if you want to communicate from any other tools, for example, you have your known tools that not customer, okay, or some other cluster you have, okay, you have multi-cluster. Both are different cluster, correct? So from there, you can communicate here by using this public IP and port. But again, this node port is again not suitable for customer because we cannot give the customer, we have to give the customer www.ravi.com, correct? Or ravieducation.com, correct? Or facebook.com, icic.com. Instead of that, if you go and tell them, hey, this is what my public IP, please hit to that public IP, in the sense we cannot remember.
So basically, one scenario here, okay. So suppose we have in Azure, I have created one public IP, okay. Then I have created a load balancer, which is app gateway, and I have assigned that public IP so that app gateway got created. In backend, I have added a lot of service like Cosmos, application management service, all those things, okay, and cluster, all those things. Okay, so that public IP, whichever associated with your load balancer, which is app gateway, will give it to customer, right, to add in the DNS record, okay, right?
Yes.
Now, once you got the DNS, where we should add that in Kubernetes application?
No. To give this particular IP, node port IP to the customer, that is not right.
No. What I am saying is my scenario here is as a real-time scenario. I need to deploy some application, okay? And it should expose publicly, okay? And application is running on Kubernetes, okay? Which has a front end, back end, everything, okay? And it has to communicate via a load balancer, okay?
Correct.
So what I did is I have created one, all the resource group, VNet, subnet, NSG, routing table, whatever things are required for security, we have done that. Then I have created a Kubernetes cluster, okay? I have deployed the application, okay? And then I have created one public IP. In Azure, we have something called public IP. You create public IP, then you create an app gateway, right?
Yes.
And you give the public IP and you create an app gateway. And the backend, you can add a lot of service like Kubernetes service you have added, okay? Yes. That their domain name, okay? Internal, that Azure has a domain name, okay? And that public IP was created, that public IP we gave to customer, hey, you add in the DNS record, so that they have created a DNS www.education.com, okay?
Yes.
That associated with my public IP, so that whenever I do ping that DNS, it will show my public IP. Now, So now coming to that Kubernetes side, that public IP, where we will use that? In suppose I need to deploy the applications, how we can use that? So that it will communicate via that. So customer can communicate via that domain.
External IP. Yeah, customer can communicate via that external IP. As you said, ALB in Amazon, if you take it is application load balancer. In application load via application load balancer, you can configure that. Simply you can create a DNS name and you map that IP address to that DNS name so that whenever customer wants, they can hit to the education.com. Correct.
Yeah.
But here, what is the drawback? The drawback is whenever you are creating application load balancer or gateway load balancer, whatever it is, so you have to create one separate IP address for one services. So for one service, you have to create one public IP. Correct. And second, in Amazon, whatever load balancer, application load balancer they have, correct, that is not having full feature like how the Nginx load balancer and F5 and in the market many load balancer specialists are there. Correct?
No, so in that case, path-based routing we can go. No, we can have one IP address and that has a lot of service. Okay, so we can go with the path-based routing, right?
Yes, you can go that path-based routing. What if you have multiple services and multiple services running inside your cluster? Why? Because cluster is not only having one namespace, correct? It will have n number of namespace. Each and every namespace having different services, correct? So this one namespace, it has normal pod, it has replica set, it has replica set and deployments, and it will have services. So all these join together in one namespace. So tomorrow I have another project, then you can create one more namespace and you can deploy all the project related resources there in the new namespace. After that, what you can do? You can share it, correct? And you are going to create service here also. This service and this service is both are different. So you are going to create service here. For that, you have to create one more load balancer IP. So like that, in your cluster, you can create multiple services. You are not going to use your cluster for only one service. In my some organizations, what will happen? In one single cluster, they may run 7, 8, 10, 20 service and all. They will create simply in one namespace and they will create a separate service. During that time, if they are running 10 services, then they have to create 10 IP address. They have to reserve in load balancer, which is provided by Amazon or whatever you are doing from outside, correct? So for 10 IP address, we have to spend a lot of money. To overcome this issue, they introduce Ingress controller. Okay. What this Ingress controller will do? And second, one is cost. Second, as I said, Nginx controller have a good Nginx controller F5. Actually, F5 is a company. Actually, they are providing a very good Nginx controller for web applications. Same like we have some other see here, there is a here. Terrafic is one of the load balancer. They are specialist on some special services. And Istio we have. This is for monitoring and traffic management and all. Istio we have separate load balancing. So by keeping one single load balancing, that is ALP, application load balance, which is given by our AWS, we will lose some features. That is why what these guys did, Kubernetes, they said to these guys, okay, you have Ingress controller, correct? Do one thing, you create Ingress controller for me, then I will ask my customer to, my developers to create ingress.yaml. So what we need to do, we have to download, if I'm going to use Nginx for web application, I'm using Nginx instance, I will download Ingress controller to my cluster first. Okay. After I download Ingress controller, this Ingress controller will create a load balancer. This will create load balancer. This Ingress control will create load balancer. depends on what you have declared inside the ingress.yaml. If you see here, inside the ingress.yaml, I have using kind is ingress, and inside the metadata, I have given name and annotation I given. What is this annotation I declared? Please boss, use this ingress Kubernetes IO. This is what I'm going to use. Why? Because here, whatever I'm declaring, backend, blah, blah, all those things, no, that whatever you are declaring, how it should execute, all the informations are available here. This is created by Kubernetes cluster itself. Okay. So by using this, what we are going to tell, we are going to tell to that Ingress controller, so what is my host and what is my path, what is the port and what is the service of the name. All these details I will give it to the Ingress controller. Then based on this information, my Ingress controller will create load balancer according to my application. As you said, if I use an Amazon load balancer or application load balancer, this feature, however, my particular application should work. For Nginx, this one, if you are using something else service, then you can use those controllers, those Ingress controllers. So based on my requirement, I cannot make work for ALP, normal application load balancers. So that is why, based on the cost effective and based on the history which I said, because of these two things, we are moving towards Ingress controller. Ingress controller also create load balancer, okay, but it is depends on what my requirement. And once you install Ingress controller, what you can do, you will get DNS IP address, correct? Here, what you got in the node port, if you see the cluster IP is not what is external IP, it is internal IP only, but only you got node port, which means whenever hitting inside the cluster, so it will convert your request to 80 port. That is the thing will done by node port. But when we are declaring this, when we are creating Ingress controller, it will give you public IP address. It will give you public IP address for service, so that you no need to worry about port, data, whatever you don't want to worry. You directly take that external IP address and you can put it in DNS, you can bind it, and you can access from wherever you want. So that we're going to do that now. So to make this, first we need to download the Ingress controller. Then we will create index.yaml. After that, this our load balancer automatically will create. Sorry, our Ingress controller automatically it will create load balancer. Once this load balancer created, we will get one common public IP address for our domain or our our service. By using that, we can access from outside. We'll go and check how it looks like. Okay. So first, I have given here installation, configuration, all those things. Well, once finish this, then we'll go for a break. Okay. Is that fine, Ravi?
Yeah.
Okay. If you go here in AWS, actually this is given by Kubernetes itself. They are giving this controller to download and use it if you want. Okay, I'll copy this. First, what I'll do, I'll remove whatever service I have. kubectl, delete, FNF, service, node, I remove. So I'll create, sorry, I'll download Ingress controller first. Okay. This is Ingress controller.
So basically, for each service we need to download, we need to have an ingress.yaml file.
For each service, yes. Per service, you have to create one Ingress YAML file.
So suppose we have in cluster 10 services running. So
example, inside the banking sector, you have cards and payments, you have loan, different services are there, correct? If you want to go to those pages, normally what you can do based on the path, you can give, if anyone hit to this path, you go to this part. If anyone hit to this part, you go to this part. Like that, you can do configurations inside of a single Ingress file itself.
For that path-based routing, should I write any policy also?
No need to write policy, but this is what it will convert as a policy.
Okay.
The Ingress,
because in function app, right, we need to write a lot of policy when you go with the path-based routing.
yes, those policy you can write. Let me show you this page. This Amazon, sorry, this Kubernetes page. Okay, there. See, if you go here inside the Ingress, they have many example file for YAML files. So this one path base / test path. Whatever you are giving, prefix you have to give / test path. Then it will route to your this to next level. Same like this also path, but here you are using some API groups and kind. See, this is k8.example.com only. In front of it, you can add multiple things if you want. Okay, server1.k8, server2.k8, like that you can add it. So like this, you have many options here to create prefix. See here, the prefix itself you can create like this. Accuse path, matches, yes or not, all those things, but that is a big topic. I'm taking here host base. So this is what I said. In one single Ingress file, you have two hosts. See, foo.bar. If anyone come foo.bar /bar, then it will convert, it will send to this particular service. If anyone come with star.foo.bar, then it will send to this particular service. Like that and all, you can give multiple paths you can declare inside this one.
Okay.
Ingress. So now download an Ingress controller. This part is done. Now I'm going to create. Even though if you download Ingress controller, it will not create load balancer until it receive the signal from ingress.yaml. Ingress.yaml we have not created so far, so it will not create anything. Okay. So now I'll go and create ingress.yaml. I have ingress.yaml. This I'll create. See, while creating ingress.yaml, this is very much important. See here, your service should have this tag. Your service should have this tag name. See here, my service should have that name. See here, my service name is Nginx Dev. This name we are referring here. Okay, this is what the service name we are referring, not label. We are referring service name. Okay. So here I will change some.
One more question. Sorry to interrupt you.
Yeah.
One more question over here. If I want to communicate to external load balancer, okay, from this, okay, then we should add external IP, external load balancer IP in this ingress.yaml file.
That option, I'm not sure. We have to check the documentation.
Okay.
So here, as controller, bus create one load balancer. So whenever my customer hit to this myfirstweb.com, then it should send that request to Kubernetes. Okay, that is what I have written inside that ingress.yaml. So I'm going to create now bi ingress.yaml. Okay, so it is there. I have not created on my own this ingress. I just copy from the document which given by them. Okay, For this and all, you will get vendor support. Don't worry. Whenever you want to do this, from Nginx FI actually provided by FI. So from FI side, they will give a support to you whenever you are deploying anything. Okay. Okay. So what I'll do, I'll save this. Then I'll run kubectl create hyphen. Before that kubectl get svc, I'll type services to check any services running. No services are running. Okay, because we removed all the services. kubectl create -f ingress.yaml. So the moment when I create, what is telling invalid myservice.com slash something I did wrong.
That name you have given, right?
Something will give double quote. So I did some, see here, RFC subdomain. Some type of mistake I did, I think. Let me correct it. Yes, I did some typo. I'll check. I'll compare both, and I will change it. Something I missed some hyphen, something like that. I don't know what is that. Somewhere something. Okay, I'll compare and I'll update this. What is the difference between these two? Orchestration engine class name engine. Backend service name port number. Maybe because of these spaces are there here, correct? Some special character, so it is giving error for that. No problem. I'll remove it. After complete this one, I'll share this. Okay. So my ingress also created. See, how can we check the services? We will check first whether the service created or not. Get SVC. Service not created. Okay. We have to create port service as well. So kubectl get ing. See, no need. See here, we got our what is it? DNS. Okay, so we got our DNS. Let me check NS lookup. NS lookup space this DNS IP. Okay, so these many DNS I have. If I go and access from this DNS also, it will not work. If I go and access from this IP address also, it will not work. Why? Because in Ingress control, I told that please create a load balancer for this particular website. So if I hit from this website, if I hit as in this name, then only my Ingress controller will allow. Okay. For that, what I need to do, I take this IP address. I have to go and I have to bind this IP address into our DNS. But here we don't have DNS, so we will bind locally. How can we bind locally? In /etc host file, we could update this information. What is our this one? My example. I'll explain you more about it. Give me 1 minute. Let me do this. Then I'll explain about how DNS also will work. Okay. So I'm putting all these 3 IP addresses for local resolution, IP resolution. Okay. So now I'll go and I'll hit this myfirstwebsite.com. My first website.com. I'm getting temporarily unavailable. Why? Because I have to create this notepad as well, or notepad as well. 1 minute. Let me check that. Okay. Actually, what happening here? We are creating this Ingress controller. So inside the Kubernetes cluster, we should have node port service should run. On top of that service, we are going to deploy this load balancer. So whenever you are accessing your site, your website, normally how DNS will work. I'll give you one small example how normally DNS will work. See, you have, this is your system. Just to think about, this is your system. Okay. Whenever you are type any website in your browser, whenever you type any website, so where it will go? First, it will go and check your cache. It will go and check your cache bus. This is what my website, github.com. Do you have any IP address? If it has, then it will give you. If in the cache there is no IP address for that, then it will forward the request to your hosts file. In Windows, it will be available. Just you check, Google it where the host file is available. It will go and check. First, do you have IP address for github.com? Then if it is available there, it will take and it will directly hit to that IP address and it will work. If it is not there in your etc host, that is your local host file, then the transfer move towards your DNS servers. Okay. Here, instead of binding, because we don't have any separate DNS servers, correct? Each and every your organization will keep their service. Even though in Amazon also we have DNS server service, but as of now we don't have separate our DNS server to add this IP address for resolution, correct? So what I did, I locally add these IP addresses. These 3 IP addresses I took and I added inside the /etc host. So whenever I hit this, first it will go and check in the cache. Do you have IP address for this cache, will say no. Why? Because first time I'm going to do, correct? Next, it will come to /etc host. First, do you have the IP address for this my first web.com? Then my host file will say, yes, I have 3 IP. You take whichever it is working, you take and you go and you hit it. See here, I declared here. So this is how your DNS will work. Whenever you are, even though in your mobile or you are in home, wherever you are hitting any web server, any website, first it will go and check your local cache. That is why sometimes we will say, clear the browser cache and try. Why? Because in the browser cache, if it has any old IP, it will keep on give you the old IP only. So that is why people will say, clear your cache and try. Okay. So first it will go and check in your cache. If it not find any IP address for that particular website, then it will come and check in your /etc host or in Windows host file. If it is not available, then it will transfer the request to outside the world or DNS server or local DNS server or external DNS server. So this is how we inside my server, I'm able to resolve whenever I'm giving curl myfirst.web.com, it is automatically resolve the IP address with the help of /etc host entry, and it will directly hit to this IP address. That IP address directly will come to here load balancer. Load balancer knows that this IP address be assigned to whom, then it will directly transfer those requests to the Kubernetes service. Inside the Kubernetes service also directly it will come to the node port only. Node port, we know actually how node port will work, right? Whenever it request coming from load balancer to node port will transfer those those requests to inside the pods, inside the services, because services knows which pod is tagged with your service by using this. See, the label is very small thing, but how label powerfully working here. If you don't give this label to this pod or node, this particular pod, what happen? This will not come and hit here. Your node pod doesn't know whether who you are. Now, I'll copy the same IP address. I'll try to hit from my server. We'll see. Not IP address, this one. myfirstweb.com. Okay. I'll copy this. I'll hit from my browser. Wait, 1 minute. Okay. So I'll hit from my browser. I'm not getting anything. Why I'm not getting anything? Whenever you are hitting, it will go and check in my Mac laptop, locally which I'm using. Do I have IP address for this in locally in the cache? My laptop is telling, no, I don't have, I don't know who is this guy, first time I'm seeing. Then it will go and check in /etc host. There is no entry. Then it will transfer, it will try to go and search in DNS. Where we have not updated this IP, this binded public IP and this name anywhere in the world. So DNS also getting failed. So that is why what I'm going to do, I'm going to take my Mac /etc host, sudo /etc host. So here I'm going to bind all these, all those 3 IP addresses. I actually tested yesterday or day before yesterday. So those entries are there. Don't think that how it came here automatically. So I'm copying. Then I'll paste here. Now, if I go to my website, first it will go to cache. No, it is not there. Second, it will go to host file. It will find, and it will hit. We are getting the output. So this is the advantage of Ingress controller. Instead of hitting by IP address, here what we did, we hit by IP address along with the port also. No one will remember port number and IP address, correct? They will get irritated. So people are easily remember these websites only. So to convert this website, we are using Ingress controller. Instead of Ingress controller, as Ravi said, you can use your load balancer also, application load balancer also. Those features are available in Amazon and AKS, GKE, whatever cloud environments are there, those are available there. But to using their load balancer, we have some drawbacks. That is what I initially discussed. 2 drawbacks we have. So due to that, we are using this Ingress controller.
So when we have Ingress controller, we should not use external load balancer.
External load balancer, you don't need directly. Actually, Ingress controller will create load balancer itself. Okay, if your environment is too big, if your environment is too big, like Hotstar, I said correct. For whenever IPL matches are going, 1 crore, 2 crore, crores of people will watch. Correct. During that time, if your service is too high, too traffic, then you can move towards the advanced load balancing concept and all. Okay, even though if you go with advanced balancing concept, even if you are bringing here a very big load balancing concept, Ingress controller will go and hit to that your concept. That's it.
We have a requirement because that we have to expose with the external load balancer. That's what I'm asking.
Oh, okay, is it? Then we'll discuss. We'll think about it because we have to think about the infrastructure, all those things. See, the Ingress controller, why we are using this is whenever any hit or any traffic coming from outside to my service, okay, instead of a public IP address, let them use the domain. In domain, whenever I'm using this domain, we can go with host base or path base, and we can add many features by using Ingress controller. That is what it is shown in the document. If you want to do any challenging work, then we have to read the document, Ingress controller document. But this is the basic setup to understand. Allow the traffic from outside, not from IP address. Instead of IP address, we could allow from website.
Okay.
So I have given here the steps and Ingress files also I have given. So you try from your end, and I given here also. So how to check Ingress controller, then NS lookup, take that IP and put it into /etc host file. Okay. After that, if you do curl, you can do the same IP address. If you bind in your laptop also, no, now if you bind in your laptop also, it will work. You copy this thing, whatever I have copied here, correct? If you copy this, if you try now in your laptop, then definitely you are able to see my contents. But don't try after 2 hours because I will delete this all those things. Okay. Till this network concept has completed, next we'll move towards Helm. But before that, if you want break, then we'll go for break. After Helm, Helm, we will go and implement CI/CD pipeline, complete end-to-end CI/CD pipeline. So don't miss the next session.
Yeah. So let's meet at 9 o'clock. Is that fine? And we'll have 9 to 11.
Yeah, for me it's okay.
Yeah, because 2.5 hours, right? Because we are extending 1 hour today, right? So, okay, so let's take we'll meet at 9 and we'll start from there.
But I'll try to finish it by 10:30. If it is extend, then half an hour some buffer time maybe. Okay. Because today Sunday, tomorrow they have to go for work. All those things are there. But I hope I will cover the rest of the topic in 1 hour or 1.5 hours. That is, if I start 9, then till 10:30.
Okay.
Okay, bye then. We'll come back.
Meet at 9, okay?
Okay, share the screen. Now we will see Helm. See, Helm is one of the advantage to deploy Kubernetes. So far what we have done, we created replica set, we created service, we created Ingress, all are different objects, correct? So Helm will help you to install or uninstall all these together in one shot. In Linux, if anyone coming from Linux background, you know what is the difference between RPM command and YAML, correct? YAML is nothing but it is a repository. If you want to install any package, if you use RPM, it will install only that particular package. It will not install install any dependency. Just it will say that if you want to install this particular package, we need this dependency. That's it. In YUM, okay, YUM repository, if you configure, what it will do, it will go and check all the dependencies. If it is not available in one repo, it will go and check in some other repos if you have multiple repos, and it will try to find out all the repositories. Then it will ask you, first I found all the repositories. If you want to install this particular package, so these dependencies need to be created. Shall I go ahead? If then if you press here, yes, then it will start installing dependencies. After that main package it will install. If YAM also could not find, then something problem we have to work around something else. But what is the main job of YAM? Same like in Windows, we have a Choco, correct? Choco repositories. So what it will do? By default, it will go and check the dependencies and it will install. But here in Helm, it is similar, but it will not check dependency and all. In one shot, it will deploy, it will create or it will delete your objects. Objects in the sense, services, deployments, whatever you have objects, Ingress, all those things. Not only that, that is one of the advantage. Not only that, so wherever in your file, wherever repeated variables you are seeing, so repeated, for example, I have, for example, here dev, okay. If you see here, version 1, version 2, version 3. So this variable is changing, correct? So in this place, instead of giving raw data, I could store this data somewhere else in the outside. I will call it. So whenever I want to deploy with this particular image, I don't want to open this deployment file. Instead, I will keep one variable file back outside. I'll connect those variable file to here. Okay. So instead, you just update the variable for image and those variable will be updated here. What is the advantage? You no need to open and edit and or copy or do anything. Say for example, if the same deployment you are deploying now in dev, tomorrow you are going to deploy in stage. So what you need to do? You have to copy everything and you have to paste it there and you have to change this app equal to dev to STG stage. Then they may say that I don't want replication count 5, I need 10. So you have to change this as well. So instead of doing these changes, what you can do, these two things you can make as a variable and you keep it in Helm chart. So whenever you want, you just outside in the Helm, you change this variable and you execute you instruct Helm to go and install now. So what your Helm will do, it will start installing by replacing those values, whatever you given in the variable file. Anyway, we are going to see now in the practical. Once that is done, you will get clear. If not, I'll explain once again. Let me know, I'll explain once again. So, notepad, done, images, Helm.
Can you please explain once again in short?
Yeah. So, Helm chart is nothing but, so whenever you are using any kind of YAML file, if you feel any data is repeated or any data keep on, it will change. Keep on in the sense, for dev environment, I have to give dev. For stage environment, I have to change it to stage. For prod environment, I have to change it to prod. Correct? So this variable is not static variable. This is dynamic. It will keep on change stage by stage. So those types of variable, what you can do, you can declare this deployment file inside Helm, and you can create a variable outside. Outside in the sense, all will come inside the Helm only, but outside of this file, outside of this deployment file, the YAML file, you can declare your variables value there. So those variables you can call here. Say, for example, you working in an organization, you are giving some deployments to your colleague who joined newly. So development testing has been done. You want to deploy in production or in staging or QA. So what you will say, see boss, this is what our Helm chart. Inside the Helm chart, this file is there. Here we are not using any raw data. Instead, we are calling variable. This variable we declared outside in Helm chart. So you don't want to open this deployment file and do changes here. Instead, you do the changes inside the Helm variable file so that it will replace while executing. Why? If you open this, one is repetitive, it is reducing repetitive task. Okay, you no need to duplicates and all. The one single YAML file is enough for you to deploy on different environments. Second thing is, just now we saw Ingress file when we are running, it was showing some typo error, correct? Due to that some error it was showing. So those types of issue might become. So instead of, see, while you are deploying on production, by mistake, if you remove this colon and you start deploying on production, what will happen? Your complete, this one will go off. Service will go off. Why? Because it will keep on tell that this image I am not able to find in this repository. Loop back, crash, loop back. It will keep on. It will create your pods. All the pods will go down. So to avoid those mistakes, as well as to reduce the repetitive task, we are going to use Helm. If you know Ansible, in Ansible also we have something called roles. Inside the role, you will keep all the files, whatever files you need for playbooks, all those things you keep. And wherever you think these variables are not static, those things you declare as a variable, and that variable you keep outside of the playbooks folder. There will be separate value.yaml folder. There you will keep. Correct? Same like here, by using Helm, we are going to automate. We are going to replace this value with variables. I'll show you now. First, we will install Helm. To install Helm, so this is the URL. Again, if you Google it, automatically it will come. So I'll go to my server and I'll install it. So before that, I'll create one separate directory for it, cd/ something called my project. Not cd. Here I'm not. dir. So my project inside, I will create one more folder called Helm. Okay. Here. See, this is not important. Even the slash Helm also you can create, but for my practice, I use this folder structure. So inside the project, you can keep whatever you want, right? I created Helm for my repository. I created this directory for Helm. Okay. So what I'm going to do, I'm going to install first Helm. To install this is the commands. So just download it. And
You have not gone to Helm directory.
no problem.
Okay.
This is installation, no? I think,
I understand that, but you
correct. I'll copy this. CP, if I'm move, I'll move. But if I install here, then Helm directory will create under project. You are right. Okay. So next, I'll run this /get. When you run, Helm will be installed. It is installed. It is not yet created. So now what I'm going to do, I'm going to create a Helm. Just we have installed. I'm going to create a Helm. To create, I'll copy and update those comments. So to create, this is the command Helm create. Then you can give any name. Okay. I'll give. Okay, let it be my Helm. So I'll create Helm. So Helm is created. Helm chat actually created. Then I say ls now. Let's say an LA. See, when you create this Helm, in the name, whatever you given the name, in that name it will create one directory. In that directory, if you go and check, all the prerequisite will be there. So now, if you see, so far I have kept my all the files inside root, not root, inside /root. See here, I kept my all the files, ingress.yaml, then service node, all these file I kept inside somewhere else, correct? Now I'm going to keep all these my templates, all my YAML file inside this template directory. Okay. Then here I have value.yaml. This inside this value.yaml, what I will do, whatever replicative the things are there, that I will convert as a value. I'll keep it the value. Then I will call this value inside this YAML file, inside this template. Okay. Now I'll go to template folder, cd template. So by default, it has, when we create Helm, correct? By default, it will create one directory, and inside, by default, it will copy all the supportive files, all the example files. So what I'm going to do, I don't want any of this. Why? Because already I have my own YAML files. I don't want to copy and paste.
We have to create this Helm chart for each and every service or each and every deployment which we want to do.
Each and every service in the sense, we could say deployments, service, ingress, all three joined together, correct? How we are able to access that our this website.
Right.
to access that website, what are the things we need? Correct? What need? Deployments we want. After that, we need service. After that, we need ingress.
Okay.
Correct? So like that, for your, if you want to create any server, or if you want to bring down any server, any service or anything, you can keep in Helm and you can execute it.
So these 5 files are the main files, which is the service account, service, ingress, HPA, and deployment.
No, not like that. Actually, here what happened, by default, they have given, you can keep in this format like that. They may give some examples. Anyway, I don't want this. I will remove it because I have my own YAML file. Okay. So I cleared. Okay. Now what I'm going to do, I'm going to deploy my, I'm going to copy my files. Where is my file? It is inside the /root. So I'm going to copy this one, service node, one file, and another ingress.yaml, another one, deploy one, I think. Let me check.
Node port, that one.
No. So /root /deploy.yaml. Deployment. Yeah, this is the one. Okay. So these files I'm going to move. I'm going to copy. So better I will copy. Okay. cp-p. From where I need to copy? Inside the root. What file I need to copy? Deploy 11 I need to copy. Where I need to copy? Dot. Yesterday itself I said dot is nothing but the place we are where you are standing. This is the place, correct? So dot, in the sense it will copy here. See now that file from root to this directory. What is that directory? Present working directory. My project Helm, my Helm templates. It copied. Same like I will copy one more file. Deploy, not deploy.yaml. Service node.yaml. So because service node only, node port.
Hey, one question here. One question Arun Kumar has asked. The question may not be correct, but I used to hear in my team that Kubernetes deployment and Helm deployment. Can you please tell me that what is the difference in how it works? Can you see the chat?
No, wait.
In the chat, there is a question.
See, Kubernetes deployments is nothing but whatever we have done before discussing Helm, whatever we are discussing by keeping all the files, by using YAML files, that is normal basic Kubernetes deployment. If you deploy from Kubernetes YAML file manually, that time also your service will work. Like just now we saw, correct? Our engineering service is working and we are able to access from outside. Why we are coming to Helm in the sense, it will make our day easy. That is why we are moving towards Helm. Wherever we repeatedly using these templates, those templates are those complete templates we could put it into Helm, so that in one command we can install or we can delete it. Let me first finish it, so that once I complete the Helm, you will understand what is Helm. Then you ask the question if you have. Unmute and ask me, because normally when I'm teaching, I'll not see this message. I'm sorry for that. But if you have any doubt, unmute and you ask, no problem.
Sure. Thanks.
So I will copy one more file, that is service I copied, and deploy I copied. Ingress. I want to copy ingress as well. Ingress. Okay. So I have all these 3 files here. So let me change name properly. Move deploy.11 to deploy.yaml. Just okay. Ingress looks good. Move service.yaml to just service.yaml. Okay. Now I have all three my files. Okay. By using this, we can open here as well. So I'll go here. Okay. Before that, before accessing that, let me give a complete full access to the directory so that while accessing from here, I should not get any access issue. So chmod 777 permission I'm giving for my project directory. I'll give I'm using -r. -r is recursive. Recursive means whatever available inside the my project, whether it is directory or file, it will give permission for all the things in one shot. Okay. So now I'll go and I will try to access slash my project. Okay. Okay, no problem. We'll go my project itself. Okay. So now see, inside my project, you have Helm directory. Inside the Helm, you have all these details. Inside it, you have templates. Inside the template, just now we copied deploy, ingress, services, all those things. So if you want to do any changes, you can go and do the changes here as well. Okay, but I don't prefer this for this one workshop. I'll go here in command prompt. Okay, so in my project, cd helm, inside that my helm. So here I got all my files. We'll open and check what is there in the value.yaml.
Can you show me that how you came to this through Visual Studio? How you have logged in? How you have came to this? This pathways you took it
This
in
one,
search, right?
this paths, huh?
How you came?
See, whenever you are going to connect here, it will ask two things. In the top, you will have whether you are going to open file from this or you need terminal.
So I will print the file from this, from the search bar. How you can do that? I missed that.
Okay. So no, for that I have to again I need to disconnect and connect.
Can you show me that?
Okay. Okay. No problem. So here I'm going to file. Say for example, I'm going to remove post or
Earlier you were in server, right?
yes, yes, correct, correct.
On
I'm
the
going
server,
here.
how you came that?
See here, I'm going into the server. Okay. Opening remote session here. So like that it will come. See here you can open and you can do that. But first let me connect it. Okay. That is coming recently.
Okay, fine. You carry on. Okay, I will see that.
Yeah,
I'll watch the recording. Just
yeah, correct. Okay, so I have copied here inside my project. I copy. I have a Helm directory. Inside that, I have all these things. I install Helm. So inside the template I have, and we will go and check what is there in the value. You click here, so you will have values like image, repositories, full, all those things. What is this? See, if you want to call any image in your CD template, I'll go vi, say for example deploy.yaml. So here image is there, correct? So you are giving your complete image name and tag you are giving here. So instead of giving this tag version 3 here, in raw method, what you can do, you declare your tag here, version 3, small v, version 3, and here what you can do, you remove it. Okay, this is not a, I'm doing in keyboard. So you remove here and you paste this one, value dot tag. One more. So what it will do, it will, whenever you are executing your Helm, it will come and it will read, it will think, okay, deployment, okay, we need to deploy this YAML file on Kubernetes cluster. Then it will come and read each and everything. Here it will come, oh, he used a variable. What is that variable? What I need to replace here? Okay, go to the dot value. Dot, where is dot value? Here. Okay, go to dot value. After that, what I need to do? Inside that image. Okay, image. Inside that, what is there? Tag. Okay, in the tag, what is the value? It is there? V3. So it will come and it will replace V3. If you keep V1, it will be V1. So tomorrow, while you are deploying, if you are going to deploy with V2, version 2, then you no need to open this file at all. Just you open this value.yaml and you change from V1 to V2 and you run the Helm chart or you deploy the Helm chart. What your Helm chart will do, it will replace this value here and it will deploy it. Same thing.
And like from where you fetch this value image dot tag, that GitHub page, you copied it something.
Okay, this is normally in this what is it, YAML language. So whenever you are declaring any what is that value in Python, so normally what you need to do, you have to use two curly braces. Inside it, you get dot value. Whenever you start with dot value, your Helm chart understand. Helm chart created like this. By default, whoever created the company, they created like this. Whoever storing his any file, inside that file, if you open two bracket, after space, if you put dot, which means we have to come and see in this place. Next, after dot, what we have given? Values. So we have to come and check here. Do we have any file called values? Here I have values. If I want to refer chart, then we have to give chart. Instead of value, I have to give chart. So this is macro programming, we could say. This already declared by the company or organization who created this Helm. So whenever you are creating this, if you read the Helm documents, like how we have Kubernetes documents, correct? If you read Helm documents, there they will mention clearly what you need to do. How can you declare the value?
So basically, this deploy file, we are putting the stuff, we are changing it like this particular deployment file, right?
Yes, inside this particular deployment file, instead of giving raw value, we are telling that please take the value from here and replace to this deploy.yaml. Insert this value to deploy.yaml. That to where we need to deploy here in this place.
Okay. So this values.yaml, like, is it a standard for all the kind of deployments, or like how this value.yaml is being used? Getting my point? Like when we are giving it in this format, so this, like, there is a lot of content written here, right?
Yes.
So the standard which we have to follow is like values, then images, then tags. So does it have all that configuration for like whatever the Kubernetes deployment we do? this particular file is having all that configuration?
Yes, it will not have all the configuration. This file they have given for example. If you don't want, instead of image, you can give something else also here. The main thing is whatever you are declaring here, the same format you have to change here as well. Instead of image, if you give something else like apple, mango, if you give mango here, then you have to mention here mango.
Okay, can you go down to this particular values.yaml and show like what all the things we are getting here? Because so service account details we are getting,
yeah.
Then pod annotation, pod labels, like okay. Service Ingress host.
Helm has all the information, whatever things we have inside the template and chart, okay? And that you are keeping a store so that you do the changes in the Helm and you deploy it.
And second, this file actually, this is all the examples they have given. If you want, you can utilize it. If you don't want, you can remove it. If you the contents which you don't.
So
want.
we will basically create our own values.yaml, right?
Correct.
Okay, and like this is just an example. This file is just an example. What this, because like in our deployments we have seen that we have chart.yaml also, like we are using particular chart. So that is having deployments, that is having HPA or whatever services related configuration. So how that chart is created, like it's a big chart. You have all those, configuration written there. So those things are created manually, or like we have some kind of standards from where we can download it like that.
See, normally whatever you are declaring inside the chart.yaml, you have value.yaml. So chart.yaml is nothing but you can create multiple charts here. Okay. When we are creating charts, no, I will let you know. We have not created charts yet now. Yet. Okay. You can connect more than one chart. How you are connect more than one file like that? You can You can use chart itself as a variable. You can call one chart to another chart. So in that situation, you can use this. And second, whatever they have given here, no, this is just an example. If you read all these things, you could understand what exactly here, what exactly is there, what we can do by using these chats. Okay. So for your information, what I'll do, I'll go there and I'll remove everything from value.yaml. Okay. So I'll give here some basic content, content.
Yeah, that will be very helpful. Like this particular deployment which we are doing, if you can, create in parallel the chart for that or the values or YAML for that will explain better.
No, I have. See, I'll copy this. Simply, I will keep this and I'll let you know. So why? Because you should not get confused that okay, all these things should be available. Then only Helm will work. Otherwise, Helm will not work. Correct?
Yeah.
It should not be like this. So I'm going to use only something like replica count. If you don't want, I'll remove that as well. Okay, replica count we need. Why? Because how much deployments you need to do. Okay. Next image, then repository, pull repository and tag. Okay, all these details are there. If I want, I could instead of here dev pipeline Ravi is there, correct? Here I will replace this value. Can you tell me how can we replace?
We can give it like dev pipeline / Nginx.
1 minute. Sorry. So tags before tags image dot
values, then dot images, image, then dot repository or the tag like
dot tag. Correct. The dot values dot image dot tag.
And like what if we want to change this value? It will be like values, then image, then repository.
1 minute. Tell me now.
2 curly braces, then dot values.
Dot values.
It will be values, right? It will be values.
No, wait. It
It
will
will
be,
value.
yeah, values. Whatever this file name is there, no, the file name only we have to give here.
So you are missing S here. That's the
Okay.
connection.
Okay, I'll
B
update.
should be a
So-
small, right?
Huh?
B should be a small or capital.
We
Small.
no, some small in the sense here, while we are accessing value, we have to keep big V, okay, capital V, but we'll try with capital and small. Okay, V
Okay, then values, then we have image,
image.
then dot repository.
Very good.
Then curly braces close. Yeah.
I updated. Okay. Now here what I do, I'll take Nginx itself version. But we don't want version, correct? We don't want version. Okay, version 1. We don't know in Nginx how many versions are there. We'll do one thing. We'll instead of Nginx, we'll keep Ravi. Okay.
Right.
Done. Now next, okay, we'll do these changes and we will try to execute how our Helm is responding. Okay. Now I made only one as an variable, two variables. Okay. One is values.image. It should be capital only because that is how they written in the method program. We'll see. Okay. I have created vi deploy.yaml. I have done the changes in both values.yaml as well as inside the template. kubectl.
So chart will not do any changes.
No, as of now we are not touching chart. We are not touching. Why? Because we have not created even a single chart.
Okay.
What happening? Get all. kubectl. Pause. What happened?
Need to reconnect.
No, it is specifically the right host or path. Okay. Wait 1 minute. I'll close this. Reconnect. Already taken from. So add new host. Okay. So see here, Ravi, you're asking, no, how can we open? See, by default, if you want terminal, you can click on terminal. New terminal. Okay. Here, if you want to open any file, click on open. Then it will come here. Which path you want, you can go and you can open it. Okay. Now we'll check whether kubectl get all.
kubectl is not found. kubectl
Get all. Why my machine is telling me? Okay. Okay. The problem is when I did AWS config, right? AWS config I did from root user. That is why whenever I'm trying to access from my normal user, it is not accepting. Okay. So Ravi, this is how you can open. So click on open. So it will ask you which file or directory you want to open. Tell them that it is my project. So select this and click on OK. So that it will.
Yeah, I understood that.
Yeah.
Basically, I have to connect the server from the search browser, right?
Yeah.
Okay.
Okay, done. What happened? We done and we are going for Helm inside this. This is what my Helm directory which I declared. Okay, so values.yaml, the dev pipeline Ravi is there and v1. These both the variables we are calling inside our deploy.yaml. Okay, okay, it looks good. Now what we will do? We will create a chat. What is that? Helm chat. So to create Helm chat, Helm create. Before that, let me type plus. So create Helm chart, Helm, create. Then you have to give any name, chat name, any name give. App, I'm giving app, okay? /my help, okay? So what I'm telling, create a Helm chart. Create Helm chart in the sense, you go to this directory and inside this directory, whatever deployment, ingress, whatever files are there, correct? And value, all the files you read it. If they declare anything inside the value, you replace those here wherever the values they have declared, replace those and you deploy this on Kubernetes cluster. That is what the meaning of this. Helm, create, app.
So this will automatically read the deployments file which we created for Ingress service and deploy.yaml, and it will create a chart for that.
Yes.
Okay, I thought like we create that chart whole pattern manually or something.
No. What is
Okay.
coming out? Sudo is coming. Someone is hacking. cd/my project. Okay, I created this one. I came now. That is why come again. Come back again. cd helm. Okay. Now here we have. So before that, I will remove all my this one. Why? Because Helm is going to deploy for us, correct? So I will remove all my deployments. kubectl get all. I'm going to remove all these things. How can I remove? kubectl delete deployments. First, we will delete deployments. Let us check. Okay, if you delete deployments, it will delete your replica set as well. Why? Because deployment sitting on top of replica set. Now, next Nginx deployment we need to remove. So, kubectl delete, then Nginx deployment. See, you are doing manual, no? These things you are removing one by one. If you are creating in a help chart, one command is enough to delete and create all those things. Okay. So kubectl.
Basically, you have to uninstall Helm, uninstall, right?
Yes, very good. Helm uninstall. kubectl. Yeah. So Ingress. So this Ingress also we are going to deploy. kubectl delete. Sorry. Ingress delete ing space. For Ingress shortcut is in ing. If you want, you can give Ingress as well. So if you see here, kubectl get all. I remove everything. Okay, I remove everything. Now, if I go and click on my first project, it will give 404. Why? My complete application I brought down. Nothing is there. Now, with the help of Helm, I'm going to create. How can we create? So Helm create, then give any name, app dot / my help. Doesn't need one argument. So Helm install, not create. Sorry. Helm install app. So explain some problems. Okay. I think what it is telling, installation failed, template, executing, nil evaluation, interface dot.
That
some,
tag you have added, right? Value.image.representation.
So
In
inside this,
value.yaml file.
inside that, I think is this small or big?
I believe small because that's the standard everywhere.
Let me
Everywhere should be a small. That's what I said.
Yeah.
check. Control save. We have saved. Let me run again.
Again.
No, that is not an issue. Over here somewhere. Repository, is that correct? Repository. I'll open here. VI template. My help template here.
Value.
Local.yaml, correct? So just see here. Typo. I think it's capital letter B only will. Okay. So image repository 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 that value image dot tag. Okay, we'll run now. We'll see. Again, I think it's capital B only. Why? Because even though if it is small, but what when you are declaring here, when you are starting, it is in their micro programming they have written like this. So you have to mention capital B. Now see,
it should be capital only, right?
Yes, it should be capital. So if you see here, kubectl get all in only one command. In Helm install, then I gave this name. This is name actually. Okay. After that, this one. It is deployed on. Sorry.
Your voice is breaking.
For everyone, my voice is breaking.
No.
I'm using same.
Your
Okay.
voice is breaking a little bit. I think.
So for us, it was good.
Okay. This is the advantage of Helm. See, to install, previously what I need to do, someone asked in the chat, correct, what is the Kubernetes deployment, what is Helm deployment? If you're going with Kubernetes deployment, you have to take all these three files. First, you deploy kubectl apply -f deploy.yaml. After that, you have to go and do kubectl apply -f service.yaml. Then you have to go with all those things, correct? So now, here in only one command, Helm install app and whatever the Helm directory. If you give that, what happened? It will create a chat. Actually, here we will call this as a chat. Okay, this is one complete chat. So it will create and it will deploy all the related objects for your service. Whatever objects are related to your service, all the objects will be deployed here in Helm by using single command. Going forward, if you want to do any change.
1 second, why a status is showing invalid image name?
Yeah.
A status it is showing in the pod a static image name.
But because I think it is not downloading from this one. They pipe. Let me check. Let me check that name. What is that name here?
should be version. The tags should be added, right?
Tag added, but this is Docker.
Have added.
But how is it logging to the Docker?
That because it's showing inactive. Spot should be inactive. Or it is-
No, for pulling, you no need to log
Oh
in
yeah,
Docker.
okay, yeah, right.
Yeah.
So Docker login.
Yeah, okay.
So dev pipeline
It should
colon
be V4.
V4. No, V4 and V1 also we have here.
We have all the versions there. So
kubectl dev pipeline the V1. Let me copy and paste here. Then we'll see. After that, it has V1. Okay, that is small V1. Okay, so now I will save this. I'll do one thing. Now I installed, correct? I'm going to uninstall. See, in one shot, all will go off. See? So again, I will install. You see?
The status is showing invalid image name. That is the reason. It should be provided, right? The pipeline class Ravi.
Correct. It should provide. 1 minute. Let me give hardcore value and we'll check whether it is variable declaration issue or something else.
It could be.
Let me check deploy.yaml. So here I'll give hardcore.
So it is
Copy
not
this.
taking that image name or something. It is
Uh,
not taking from him there. Then from where it is taking that image then?
can
No,
you
it is not
describe
taking.
one of the pod to see like what is the error in the last? That
No. We can go to describe, but what happening? It is not taking the image
no,
name.
it will show that image name. It is showing in this.
When you describe the pod, yeah, you should go to that service
Some
log.
yeah, something valuable information should be there. Describe pod. Then the no describe pod and the pod name.
Pod name.
Mm,
Then pod
Yeah,
name.
just one name. Is describe pod.
Not
kubectl
pod.
describe pod.
Then pod name.
Yeah,
No, pod, not pods.
wait.
there and remove the second pod also before nginx also. Yeah. Error from the server. The pod is not pod.
Wait. Describe pods only to come. Let me check randomly.
No, it won't describe the pods. Like that. To give the specific name.
Describe deploy.
Deploy, why you are doing?
Just I'm trying to check from deploy. Okay, wait. First we'll give the hardcode value and check. I'll take this as a backup. Okay. I'm going here. Start this P1. Something. Whatever. It's just to control this. Okay, nothing is there.
Already uninstalled.
So in the declaration, we done somewhere else. We did. Okay, let me first replace V1. Okay, then we will try again. Let me uninstall again. I'll replace this one. Values dot tag. Okay. Okay. Installer. Invalid image.
No, you have to uninstall and install, right?
No, I did uninstall. I did. Wait, here only something is the problem. So tag tag image. 1 minute. I suspect something problem on my copy and paste. So I'll go here. Helm, correct. Yeah, I'll do one thing. I'll copy from here. Paste it.
Validate, na YAML validator.
Okay. Okay. So Control S. Now I'll go to Lloyd. Tag we have, correct? Okay. Now
So
check values that is saved. Values. Save. Okay. Now I'll go for install again. Actually, I did some formatting here. Something I did because I copied here in the
communication issue that I understood.
Okay. So
Tag was inside the full policy.
correct. So this is the advantage of Helm. So like that, wherever you want to make your automation, like wherever your variable keep on changing, those place you can use variables, and you can call these variables inside your YAML files. Okay. Okay. So this is the basic understanding of Helm. If you have any confusion, you repeat this recording so that you will come to know how simply we could make Helm, and how we could replace the variables. Now Helm is done. Okay, my everything is looks good. Now what I need to do, I have to move this, keep all this code to Docker Hub. Sorry, not Docker Hub, GitHub. Why? Because I'm going to
Now chart you will not use?
Chat GPT.
Chart.yaml.
No, that I'm not using now, because first let me complete CI/CD demo. Okay.
Okay.
So we have completed Helm. Now we are moving towards CI/CD pipeline. First we have to configure CI pipeline. After that we will move towards Argo CD. Okay. Wait, I'll connect my this one. explain you. Okay. Okay. See, we have already our help, correct? We have already our help. Now what we are going to do, we are going to push whatever file which is available in Helm, we are going to push in our GitHub. Okay. So all the deployment file we will push into GitHub. At the same time, we will keep one registry, image registry. What is this image registry? Our Docker Hub. Okay. Inside the Docker Hub, so inside the Docker Hub, we are going to copy all our images. Okay. The moment when images is updating, creating, inside our GitHub action will it should run. What it should happen? GitHub action should run. So whenever you do any changes here, whenever you do any changes in your any of this file, which file? Which is available inside the Helm, right? If you do any changes inside the Helm file, so automatically what your Helm should do, whenever you are creating any deployment, automatically, whenever you do any changes, then you have to push your code to GitHub. Say for example, version 1 to version 2 you change. After that, you have to push that code to GitHub. That's it. What this GitHub will do? This GitHub will change your Helm charts, Helm directories. You have version correct. That version it will go and change. The moment when it is changed, what happens whenever you push this code? These are the updated code, correct? Whenever you push this code, it will go to your GitHub. When GitHub receive this update, suddenly what GitHub will do? GitHub will go and change the tag number here, where in this values.yaml, this tag number, it will change. Who will change? GitHub will change. GitHub action change. Whenever the tag is changed here, whenever the tag is tag value is changed, our Argo CD capture that. Here we'll keep Argo CD. So we'll keep this Argo CD. Whenever that tag value is changed, whenever tag value is changed in the Helm directory, when inside the GitHub, it will trigger to your Argo CD. Argo CD, what it will do? It will go and do the deployment on your cluster, Kubernetes cluster automatically. This is Kubernetes cluster. Okay. So
let me correct me if I'm wrong. So basically, whatever the deploy file, service file, values.yaml file, it will be in my local. I will push to some git add, git commit, all those things. It will go to the GitHub action. Based on that, that pipeline will run, right?
Yes, correct. See.
So where that now Docker image will come?
No. Two things will happen here. Actually, whenever you push your code, okay, the code will go to directly Docker. It will convert as an image and it will go to Docker Hub. Okay. Next, inside your GitHub, it will not only push the code to here, and even though it will change the tag inside your wait. So it will change your tag here. V1 is there, no? Automatically it will change the tag. When the moment it is changing, capture by Argo CD, and it will deploy to Kubernetes cluster. Let me go to practical.
Yeah.
Okay. Once that is done, so that you will get a clear idea. So we'll go one by one. First, what we'll do, we will create one repository in the GitHub. Okay. So we'll go to GitHub. I'll create a new repository.
The repository you are creating Docker Hub, right?
No, sorry, GitHub. So I'm creating new repository. Already 3 repositories are there. Now I'm going to create new one. What is the repository name? Something will give my app. Okay. I'm declaring publicly. Don't give space at all. Okay. Public and add readme file. I don't want. Okay. Create repository. Okay. I have created my repository here. Now what I will do, I will go to my server. Okay, I'll go to my server. Is this the one latest one? This one? I'll go to my server where I have a Helm directory inside my project. Okay, so whatever I have here inside the Helm, I completely remove. Before that, what I'm going to do, I'll create one directory called .github. Okay. Inside it, I'm going to create one more directory called workflows. Why I'm creating here? I'm going to, okay, not here, inside the Git, I have to create RM. Okay, I'm going to create inside the .github. Here. I'll tell you why I'm creating this GitHub and workflows, all those things. Now, here I'm going to create one file. That file, something you can give whatever file you want, something like pipeline. So in this file, what I'm going to declare, how my pipeline should execute. Like just now I told, correct? This one diagram I have shown, and there first whenever you are pushing, whenever you push your code to Docker registry, no, sorry, not Docker, GitHub. Whenever you push your code to GitHub, what GitHub needs to do. That is what the steps we are going to write here. Okay. So I already have those steps. I copy and I'll explain you. I have GitHub action. Okay. So this I have. I'll copy here and I'll explain step by step. See, this is nothing but you may have heard that pipeline, correct? What is the pipeline? Pipeline is nothing but stage by stage moving towards your deployments. The core concept of pipeline is you have to deploy your whatever files you have, correct? Whatever the YAML files, those YAML files or those services files you need to deploy on a Kubernetes cluster. So in between, we have CI/CD or automation so that we no need to do manual work. for each and every time. Okay. So for what I did, CI, I declare name is CI. If you want, you can change this name. Okay. CI on push. When this workflow should start, whenever they are pushing anything, where in the main branch. Which main branch? Just now I created one directory, correct? Not created, I'm going to create, correct? So in that directory, whenever they push in the main branch, mention which branch also you can mention. So whenever you receive any update in the main branch, then you have to act. So here just they given ignore Helm. If anyone go and do some changes inside the Helm, so ignore like that they have mentioned. Okay. If you don't want, you could remove it, no problem. For example, if you have any readme.file here, if anyone go and do some changes in the read.file, then this pipeline will trigger, correct? So that is why if you want to ignore any files, we can ignore it by giving these paths. Okay. You no need to give help path. So see here where you have installed inside this your correct. You no need to give slash root slash my project, all those things. Wherever your Helm is there, from there automatically it will take. Only thing is in front you should not slash, just start with Helm. Okay. Next, jobs. We are going to declare jobs. So the jobs is nothing but stages. What it should do in the first stage, second stage, third stage, all those things. Here for simplifying, I have only 2 stages I'm running. One is build, another one is update help chat. Okay, we could add one more this also. But first we will run and we will add it. So here what I did, what I mentioned, you may ask who written this code and from where you got all those things. See, in GitHub Action, if you go to GitHub Actions, GitHub Actions, marketplace. If you want to write to execute your Nginx, you can go here, for example, Nginx. So here they will have some sync, configuration, setup, all those things. From here, you can read it and you can create. See, tags to, this is the one. No, lost. This one, Nginx sync. Same like if you have anything else, by default it is giving here itself. See, metric, super checkouts. See, if you want to do any checkouts, how can you do that? See, they give an example. They already create inbuilt. If you give accent / checkout, then you have some options. By using these options, what you can do, automatically it will check out. Okay. So like that, by seeing this documentation, we need to create our pipeline and we have to search what are the things we have to add and what are the things we need to remove. All those things we have to search. Okay. So I have added this here. Checkout. What I'm going to do? First, I'm going to check out my repository. After that, okay, this pipeline is running, correct? This pipeline will, where it will run? It will run on your GitHub instance. GitHub will take care of this. It will first create one Ubuntu latest instance. On top of it, it will automatically execute. Who will take care of this job? GitHub it will take care. We no need to do anything. Okay. Next, someone operating. I think. Okay. See. Yes. Okay. Next, it is like this. Okay. What we have done, we have set up Docker buildx. Buildx in the, it will take care of build. we are running command, correct? Docker build -t dot or something, that it will take care. Then it will log into Docker Hub. Why? Because once the build is happened, then we need to push the directory. We need to push the images to the Docker Hub. Okay. So for that, we are using we need username and password, because this is GitHub, that is Docker Hub, correct? Both are quite different. So the GitHub has to push the images to Docker Hub. Okay. So for that, we need username and password. We will declare that as well here. And build and push Docker image. So what it will do for push, actually here build and push they have mentioned, but normally they'll do they are doing build and push. So what here we are doing, by using Docker file, docker.file, actually that docker.file we have to create here. Okay. So here docker.file will be available. By using that docker.file, it should create an image. It should create an image and it will push it into your it will create an image and it will give it will keep the tag. So here Docker username is, we have dev pipeline / Nginx, here it is there, no, here it should be Ravi. Then here the version 1, version 2 we have mentioned, correct? So it will randomly take GitHub run ID. So whenever GitHub action is running, during the time it will generate one run ID. That run ID it will update here. So whenever you do any changes, so what our GitHub action will do, if it find any changes on the main repository, what it will do, it will build and it will create an image and it will create an image. Okay. Then update the Helm chat. This is second job. Okay. So what it will do, it will come here. Again, it will run on Ubuntu latest. One, this job is completed, then that instance will go off. Here, one more instance will create and it will needs build in the sense, before executing anything here, this build is there, correct? This build job should be completed. Why? Because randomly it should not go here and there, correct? So that is why I'm telling here, boss, before you starting, let complete this build. If it is not complete, then don't do these things. Okay. So that is what the meaning of needs. And after that, we have steps called, again, we are doing the checkout, git checkout. Here, we are going to give a token. Which token we are going to give? We are going to give GitHub token. Okay. For login and do checkups, all those things. Before here, we given Docker Hub username and Docker Hub token. Here, we are going to give GitHub token. Okay. Then update the tag in Helm. Okay. So this will take credentials. Okay. Then it will go here inside the Helm chart. It will change the tags. Tag in the sense, whatever tag colon available, whatever it is coming, star, dot star in the sense, it will select all the things and it will replace with tag colon and GitHub runner ID. Okay. Where it will replace, it should go Helm, my Helm values.yaml. So inside this, it should go and update. So that is what I said. Whenever you push, automatically inside your this deploy.yaml, sorry, not deploy.yaml, yeah, value.yaml, this tag address will be changed automatically. Okay. So this we have mentioned. And finally, what we did here, whatever we did the changes, we are pushing the changes to our we are pushing that changes to our GitHub. Okay. But because whatever changes we are doing, that should be pushed to there. So for that, we are configure like username and names, all those things. Under git add, whatever we are doing manually, it will do git add. After that, it will do git commit. Then finally, it will do git push. When you when you give git push, automatically it will happen. How it will happen? Because we have given here secret.token. So this is the stage we have mentioned. So this is how the GitHub action should work. Okay. Let us see it is working or not. But before before running this, we have to update these three tokens, correct? Secrets, Docker Hub username, Docker Hub token, after that secret.token. All these three we have to update. Where we have to update? We have to update in um, git so not git, yeah, GitHub. We have to update in GitHub. So I'll come to GitHub. Okay, so this is my user dev pipeline. So I have already created my app. Okay, so what I'm going to do, I'm going to push all my updated files here, right? So where my updated files is available, the updated files are available cd/my project. So whatever I have here, I have to push there. So before pushing, I'll create one Docker file which we created yesterday, correct? One index file, both we need here. So vi let me take those a Docker file. Inside that, what we have mentioned yesterday from Nginx. And second, copy. What I need to copy? Index.html. Where I need to copy? Let me take that path. Okay. One. Yes. Yes, sir. Okay. These are the okay. So this is what we have done, correct? So we'll create index.html also here. So index.vi index.html. Inside that, I have to paste that HTML code. This one, it should work, right? So I'll paste it here. Docker contain, instead of that, I'll give something else. GitHub. Okay, so I have all the files, Docker file I have, index file I have, and Helm I have, all these things we have here. So now what I'm going to do, I'm going to install git install yum install git install git. Done. So we git init initialize. Okay, next git add dot git status. Okay, git Submit. Name. Update. One minute. GitHub, inside the GitHub pipeline is created. That's correct. 1 minute. CD. Okay. So EC2 user, right? It's jumping back to use EC2 user. CD my project. Git init already done. Git add dot git commit. Okay. Then this is
Where is the file that you have created the pipe CI file?
no. CI, that is what I'm looking. Wait. That is inside the workflows. Inside this workflows, it will be there. It should be there. That is not there, correct?
Then it should be pipeline.yaml file inside the workflow.
No. That I inside the pipeline.yaml. Let me check.
So inside the workflow, nothing is there.
Wait. Dot GitHub. Okay. VA. Here we could give some name. That's something CICD dot YAML, something like this. Let me do this. Okay.
Why you kept CI/CD YAML.swp?
You can give anything. CICD just I given for reference. CICD.
Okay.
If you want, you can.
Okay, that I know.
Yeah. So you have GitHub. After that, you have workflows inside it. After that, inside it, you have CICD YAML file. Okay. Now,
Token password you have created? Token?
that will do. Will do on that. So now I'll go to cd/project. My project. So my project. So here git status. Okay, newly added one thing, right? So git add dot git submit name reports. Okay. Right. So now I'm going to push it. So to push, normally Git has changed. Before it will ask the username and password, but what happened? Now it has changed. It has change, like we have some other method. Let me go there.
Earlier we used to do git login, right? Something like
Yeah, it will not accept now. Okay. So what I will do, I will go to git branch yum main. I have to we have to do this. So before directly we could go with our credentials. Okay. Then I have to go and add this remote add origin. So to remote add origin, I need GitHub token. I need. Okay. From where I could get this token? In a sense, you have to go to your GitHub. Okay. In the GitHub, you go your there in take your profile and go to settings. Go to settings and come here. Then you have developer settings. Click on developer settings. Here you go to your personal tokens. Go to classic token. Okay. So here, if you see, I have already created one. If you want new one, you can generate a new personal token. You can generate it, or you can create a new token. Okay, that will give you token. This token I have. I stored here. So what I will do, I'll go to my codings. Go here. I copy this. So I'll remove and let me copy this one. And you don't share this token to anyone. After complete this, I'll delete it. Okay. So now you will see it is added. Okay. Now what we will do, we'll directly go and we connected our Git with this one. Okay. We connected our server with Git. Now what we will do, we directly main. So here it is getting failed. Why main to main? Okay, no problem. If force. It is telling that already on main is there, something like that. So now I'll go and check in my Git. There is this one. Go here. I'm going to repositories. So this is my app repository. I go there. Yeah. I did wrong. So I have to give here. It went to CI/CD. Let me do one more thing. Git remote. I have to give this one. If that is not working, then we'll take that one. Take this. Remote already exists. The remote token already exists. It how to remove this remote. Okay, we'll do one thing. It actually what happened? It went and sit inside the CI/CD. Okay, here. If you see here, if you open CI/CD, here I do see some workflows. Correct? I do see some workflow. Inside that, whatever we have Helm, Docker file, already all those things are there. If I go to action, 2 minutes ago, this action was done. What is this action? So first it was build my Docker file where I had this one, correct, in index.html and Docker file. So taking this index.html, Docker file, what it has done, it has created an image and it will push it to here. Okay, the build image, and it's built and it pushed to our Docker hub. Let me go and check whether it is pushed to Docker hub or not. So this is what my Docker hub. Where is my Docker? Where is my this one repository is here? Again. 3 minutes ago, it came to dev pipeline engineering.
Can you hear him? Anyone?
Hello.
Can you
No.
hear?
Able to hear me?
We cannot hear you. Your voice is very low.
Very low.
Is it? Now?
Yeah, now it's fine.
Okay. So what happened due to this confusion happened due to I gave that this register CI/CD pipeline, right? Okay. Now what happened here inside the Nginx it came. Why it came inside the Nginx in the sense, if you go and check in my CI/CD, here what I have mentioned, push where it need to be pushed, it should push here in the Nginx. Okay. So I don't want to push it inside the Nginx. What I will do, I will push it into somewhere else. Why? Because why it is not asking username password in the sense already for CI/CD, what happened while pushing it should you should give the credentials, correct? For CI/CD, if you come here, for CI/CD, I have already updated tokens here when I was testing yesterday. Okay, by mistakenly I given the same CI/CD repository only. That is why it is not it was not asking any this one. If you see here, I have updated my tokens. Come in the settings. It is this one password and authentication. One minute. So here I'm going to what is this GitHub? Right, this setting. See the settings here. Developer settings we're taking token, but we will update the token here. Wait. We'll update the this one. Secrets. Yeah, see here. So what I gave settings here, but you have to go to the CI/CD, whatever your repository is there. No, that repository setting you have to go. You have to go there, and here you have secrets and variable. Here actions in the sense GitHub actions. So these variables will use by GitHub actions. So 3 days before, what I did, while testing, I have added here token, username, and password, all those things. So this is Docker password, Docker username. This is GitHub username. So all these three I'm using here in the action file. Okay. If you see here, inside this action file, I'm using Docker username. Okay. After that, if you come down here, I'm using Docker username and password. Okay. After, in this space, I'm using secret.token. Secret.token is nothing but our GitHub token. All those things already I have added. Otherwise, you need to generate and you have to add it here. How can you create username? Username, you knows that, correct? Docker Hub token, just now I shown you how I taken the token from here, correct? This token. So this is what the Docker Hub token. And after that, if you want to create GitHub token, correct? So here in my repository, in my CI file, I have mentioned that we have to push this code into GitHub, correct? So when you are coming to GitHub token, so go to GitHub. Same, just now I shown. So this is my GitHub, correct? So come to GitHub, go to the settings. These settings you need to go. And here you will have developer settings. So from there, what you can take your personal tokens. And you can update it. So from here already I have token, that is why. So I used the same token. Okay. If first time you are login, then you can have the option to change the tokens. Now we'll come to here, and our CI/CD pipeline is running fine. Where inside the CI/CD, my pipeline is running fine. Okay, just now I ran. Now for your this one, what I'm going to do, I'll go and change something. Small changes I'll go and do in Helm directory. When I do any changes inside the Helm, what it should happen now? It should okay. If I do any changes, it should do any change. If I do any changes, say for example, I'll just add a 1122 here. Okay, I did changes. I'll come in here, save these changes. Okay, that is .html because it is created in the root. I'll go here directly and change it. Okay, CI/CD. Okay, so whenever I do any changes here, okay, this is coming. Okay, if I do any changes and I save it, after save, what I'm going to do, I'm going to push it. This is what normally we will request application team. Okay, application team, have you done your job? Yes, we have done. Okay, now push your code to our repository. Which repository? Go to CD, my project, there, git status. If you go to git status, it will tell you this and all. There is some changes in these files. Okay, so now git add dot git commit -m updated 1122. Okay, just okay. So next, what we'll do, we'll push git push. When you do git push, see here, automatically your CI pipeline should start. Okay. Refresh. See, pipeline. So your pipeline is running here. CI/CD build is going. If you want to see more, then you come to action. So in action, your pipeline is running. So what it is doing in your build. So if you expand, it will give you all those things. Check out those it has done. After that, it is going and changing the tag. That also completed. Both are completed. My CI part is done. Okay. Now I'll go and check whether it is really changed in my this one or not. Correct. So where I have inside the CD. I'll come to CD. So here inside the Helm, inside my Helm, there is a value.yaml. Inside the value.yaml, see here, tag has been changed. If we do another time any push from client end, if they push anything to the registry GitHub, so what happened? Automatically, these changes will do, and it will create an image, and it will send that image to your Docker Hub. Let me check whether images came or not here. So this is my Nginx repository. Here only it is coming. I supposed to see here. 2 minutes before this particular changes was happened. This tag has been, this image has been updated to Docker file. Okay. So our CI part is completed. So whenever you do any changes, where in the index.html, your Docker hub, it should your what is it, Helm chart, inside the Helm chart or inside the Git repo, automatically that code should be uploaded in the GitHub first. Then it will build an image. Whatever you did the changes, correct? Those image it should build. It will send to GitHub Docker Hub repository, and it should change the tag value of here. Okay. Now we will go and install Argo CD. What Argo CD will do? Argo CD will take these changes and it will try to deploy on your Kubernetes cluster. Still, whatever we did changes, that is not deployed on our Kubernetes. It is here only, still in our CI/CD pipeline only. It is not deployed on our Kubernetes cluster. For that, we'll go and we will install Argo CD. Yeah, see Argo CD. So this is what the you create namespace separately for Argo CD. I told correct, when we are discussing about namespace, you can use two different namespace and you can create your multiple applications. So for this CD, I'm using different namespace. Okay, so I'll create.
Is this GitHub repo shared with us if in case we want to practice?
Yes, we'll share.
Okay.
All these file, whatever it is showing there, correct? I will ask Ravi to share with you. Then this. So normally what this YAML will do in the sense, it has all the configuration of Argo CD. Automatically it will install. Who gave this URL to me? It is given by Argo CD and Kubernetes itself. Kubernetes is telling, if you want to deploy Argo CD, then we can go and we can use this particular YAML file. That is what given by Argo CD. Okay. So simply, if you go and type that Argo CD install in Kubernetes, then you will get all these informations. There you have a separate dedicated page. Okay. Now what we are going to do, we are going to create one load balancer service for UI. UI in the sense graphical interface, you can access it. Okay. Sure. See, I'll take this. Okay. What we have done, we have patched this particular service with our Kubernetes. Then finally, we will get load balancer services. Okay. So this load balancer, Ravi, you asked it, right? So can we use different load balancer? No, one service, one load balancer you can use. So here we have already one load balancer. This load balancer is not part of Ingress. Okay, it will communicate with your load balancer, outside load balancer. Okay, so now why? Because most probably this load balancer, by using this load balancer, internal communication only we will do. Okay, that is how they have created. This is ready-madely created by Argo CD. So same what I'm going to do now. I'm going to take this and I'm going to access from outside. This they expose their Argo CD in the website. So it is asking me show the details. It is telling that this is a danger because it don't have any certification and all. Why? Because I created very normal this one. So we have got Argo CD username, correct? We have got Argo CD page. Okay.
The username you can find a password in the configuration file, right?
Yes. So username here, and if you want password, then you should go to your there we have one secret file. Inside the secret file, we have the password. So let me check that. CD. So we came to the end. Give me some more time so that I will show you live end to end this one. So my project inside that, sorry, kubectl get secret hyphen n Argo CD. Why? Because as I said, Argo CD created its own what it is created namespace. Inside that namespace only, he created all the services, YAML file, all those things created inside this Argo CD. It will not. It did not disturb our default or anything else. Okay. So here we have a file called secret. Okay. We go there. Kubectl describe
Or
for then
Not for describe secret.
sorry, describe secret.
No, you have to give the namespace name hyphen n.
hyphen n Argo CD.
Argo CD. So what happened? Here we have password. Wait. Secret. Initial admin secret. Sorry. We have to open initial admin spot. So Wait.
Just try.
No, initial, it will be inside the initial only.
Yeah, just try kubectl -n argo cd, then get secret, then secret name -o YAML.
Correct.
No. Wait. Not describe. Actually, we have to go with edit. Actually, that one is admin secret only. We have to go with the edit, not describe. Describe will give you the creating process.
That is what if you do -o YAML, it will give you the YAML file and you will not be in the VI.
Yeah. Okay.
So right now you are getting into VI.
So I taken this. Okay. So next, what we can do, we can convert this as a this one from base 64 echo. So decrypt. We have to decrypt it. Okay. So base 64. If you do some, you will get.
You have
Password.
encrypted it. To decrypt it, you have to give -" decode.
Oh, sorry. Hyphen decode. So here you take this password. Let's see. Okay. So let me save this password so that I need the next time. So that our Argo CD, we are able to see the Argo CD here. So what I'm going to do, I'm going to create new app here. Okay, new application. So here I could give any name. So my app I'm giving. So okay. Next project, let it be default. And here sync policy is not manual, it is automatic. What is mean by automatic? Whenever there is a change in the tag inside your repository, whenever there is a change inside the tag here in your GitHub repository, automatically what it should do? It should take all the files from here, all the files from GitHub, and it should deploy on your Kubernetes. That is what the action we are going to do. Here. So that is what the active. Then we go for
At the repository URL get.
automatically it will come. Okay, I have to take the URL from here. This is my repository, correct? This CICD. I have to take the repository URL from here to copy, paste it here. Paste it here. The moment when you paste, you are automatically it will take your path. Helm / my Helm. Okay. Then this is destination where you need to deploy. Kubernetes by default it will come. You select Kubernetes itself. Namespace default. That's it. So when you are create, see your creation will happen. This is your, see it is synced. Okay, it will sync with your all the deployment. See here deployment is started. Why? Because just now we have done some changes in the index.html, correct? So that deployment is running. some pods are deleting, some pods are creating. Why? Because the new deployments during that time, this will happen. Okay. Let me refresh our sync again. Synchronize. So all are looks okay. Let me check here. What is my myweb.com? See, it is coming. It should work with container, correct? Now what I will do, I will go and do the changes here and push it. Where is my exec here? I'm going to do some changes here. Oh, okay, it should work from GitHub action. Okay, Control S, into my project, cat index.html. It should work from GitHub action. Okay, git add dot git commit -m double quotes updated. One is added. Next, I'm going to use git push -force. The moment when I push git, what happened here? Pipeline will start running. So if I refresh, I could go to actions. See here, pipeline has been started. In this, only two stage I have written. One is build. When you are building, during the time, whatever I did the changes index.html, that should move to GitHub, this directory, and create image and send that image to GitHub. Here, and next job, what I have mentioned, whenever you see any changes in the directory, you come and start your deployment. See here, deployments are started. It is going. Once these deployments
selected the automatic deployment, and why we have to sync it?
Very good thing. So this sync is by default 5 minutes or 10 minutes. It is giving by Argo. Instead of waiting for that, I'm doing the sync manually.
Okay.
Yeah. Okay. Now I'll go and check whether my changes is reflecting here or not. My changes not reflecting. Let me check.
The path, I think your GitHub path is different.
1 minute. In CI/CD, if I check, we can come to know. 1 minute. This. Okay. So here, CI. Okay. So we have to check somewhere here. Nginx, correct? But actually, what is our repository? What is the repository I given in the GitHub action? Let me check that. It will go on changing into Nginx, but in GitHub action I given CI/CD. GitHub. No. Sometimes what happens, even though if you do sync manually also, it will not work. You have to wait for this one, this trigger. Something in deployments happening. Let me check the differences. See, processing, okay, no, processing. Design manifest. See, the codes and all, it is changing. It is coming from Ravi. It is taken from Ravi, but we have given there Nginx. That is the problem. It is keep on triggering from Ravi. We did something wrong in this file.
Some repo path.
Okay, I'll give this
Change.
Nginx. Wait, here what we have given.
Their path name is Ravi.
Here tag is changing. Okay. Something we did mistake here. Let me change it to Ravi. You see. Username / Ravi. Okay. Do some changes here. We have this. This hit add dot
Horse.
It should go.
Now you should go to the Ravi
Yeah.
in the project way.
It came to Ravi. It is working. See here. Now, how the CI/CD complete CI/CD work in the sense, whenever you do any changes, you tell your developers who doesn't know Kubernetes, right? Who doesn't know how Kubernetes will do. So you tell them, boss, you do changes in your code and push it to this repository. Which repository? Ravi's repository. Push your code to GitHub. Just push your code to GitHub. Once you're done, you don't need to do anything. All those things will be taken by GitHub action. How it will be taken care? We have mentioned the steps inside the GitHub action. What you need to do? If you get any update here, what you need to do? That we have defined inside the GitHub action. It is very minimal GitHub action actually. Okay, so you can add multiple stages here. You can add a dev stage, QA stage, all those stages you can add in the GitHub action. As well as you can do multiple checks, even though you could add here some scanning, image scanning, code scanning, all those things you can add it. How can we add image scanning, code scannings and all? Then you go to your CI file, GitHub CI file. There you can add more plugins like this. This is ready-made plugin which is providing by GitHub only. You may think that I created something like that. No, it is ready-made. This plugins we have. By using this ready-made plugin, I just replace this username and password and just I'm playing around it. Okay, so like that in GitHub action you have multiple. If you go to GitHub marketplace, talent marketplace, I went correct. So if you go and check, if you put your requirements, then it will give you the already already plugins, whatever they have created, their plugin they will give. See here, action/checkout and at the rate 4. This is nothing but already it is mentioned in they have created their plugin. So inside this plugin, they have mentioned all those things. If my user is mentioned like this, you have to react like this. Okay, so I am using just their plugin. I have added my credentials and whatever the steps, these steps we can declare here. First step is build, and second step is what we have done. We have done update help chat. Okay, if we want, we can add one more steps also here. We can add push steps only for this. After this here, this place, after 54th line, we could add just we could add one more line here, like push, just a push, and you have to run on like that. You can add it and you can edit it. Let me try that whether it is working or not. Finally, if we try, if it is working fine, then we'll wind up the call. So here in so here we have only two stages, correct? One stage called build, another stage called update. Now what I'm going to do, I'm going to create one more stage. I'll copy this. I'll copy complete this. Okay, I'm going to paste it here. So here, what I'm going to do, I'll remove, sorry, let it be, and I'll remove these steps. I don't want any checkout. Report repository, no need. Okay, let it. I don't want to do any tags here. Just I will push the command. Okay. So I have added here one more this one called push. Okay, I have added. Let me git add dot git commit -1 data git push -1 force. If you do this, what happens? Automatically it will go on. It will come to my GitHub. So it is started. I'll go with the actions so that I will see some more information. Updated. Okay, it is taken push. Okay. I did one wrong. What I did in the sense, I did need, correct. This is something wrong. I should give that this one. This one. So needs this job. Once this job is complete, then only it should come. So with that, it commit. Okay, I have not saved it. I have to save this way. This git add, git commit, then it push it forcefully. So now I'll come, see it is failed. Okay, so now I'll come again. I'll click on action. Again it came. 3 jobs should be there. See, one is build, another one is update into the Helm chart. Then it will push the images into my repository. Okay, when it is pushed to my repository, automatically your changes will happen. Automatically it will start deploying, and you can see the changes in the service or application. But here we did not do any changes, so it will come the same only, because we have not done any changes in the index.html, correct? So it will come only this one. Okay, so this is how we are doing end-to-end deployments by using CI and CD tools. So now we have not entered into this Kubernetes itself, but we deployed our application. We change our source code, and those source code is reflecting in my browser, which means my application, something whatever I want to make from my application, that is happening without touching anything inside the deployments, correct? Just uh, you can use any one of jump hosts. In the jump host, you just log into your GitHub. After that, just you push the code. Rest of the things will take care by CI. CI is nothing but here we are using GitHub action. CD part we are using for Argo CD. These both join together, and it will finally deploy our code to our Kubernetes cluster. Okay, yeah, I hope that's it. This will give clear idea about how the CI/CD pipeline is working. See, for these steps only we are calling pipeline. If they say someone, if you ask them, no, what is pipeline, all those things. So these are the pipelines. Pushes is not happening. I don't know why. We have to check it. Commit command, global user email, dev from, nothing to commit, working quickly. Oh, there is nothing to change it. Why? Because we have not done any changes on the index.html, correct? So it is telling. Yeah, that's it from my end. Ravi.
Any questions, everyone?
No questions. Thank you very much for that session.
Yeah, you're welcome.
I hope the session was helpful for everyone.
Yeah, it's quite a lot of information in less time.
Yeah, because just it was 10 hours of session, right? And in that 10 hours, it was just like a program, whoever in the observability background. Because I used to take care of the training for observability, and I have seen that most of the people are facing a difficulty on Kubernetes, Docker, CI/CD pipeline, Terraform, all those things. When I talk about, okay, the configuration through this way, okay, they're completely confused. So I thought, let me run one program so that they can understand in deeper way. Okay, so that whenever they wanted to do any configuration in observability, right? Because nowadays in the market also, observability tools also can be configured, right? Configuration as a code, we used to say, all those things that using by Terraform, using by Monaco, many tools. Okay, so that is the reason I thought, let me run a program so that they can understand in better way that Docker, Kubernetes, all those things. Because nowadays application, most of the application, right, when you deploy any monitoring on their applications running on the cluster, OCP, AKS, EKS, GKE, Lambda, function, Azure function app, all those things. Okay. So that is the reason I thought, so they can understand the container-based application in better way. So any questions for others?
So Ravi, are you taking any sessions on observability setup through Terraform and all that?
Actually, for training purpose, sometimes some of the configuration I used to do, okay, like management zone, yeah, application creation, synthetic creation, but not everything. Everything is not possible, okay? Alert profile, any alert, custom alert creation, because a lot of JSON and their configuration changes are required, right? So, but at least I can show you that so that you can understand and you do a lot of changes, and then based on your accordingly, you can do that.
Okay.
probably I will be running one more batch for Datadog, okay, in somewhere in June, okay, and one batch for this open source completely. So I will be running something like OpenTelemetry, Prometheus, Signos, Grafana, Elasticsearch. So like complete open source, send data to everywhere with the hotel agent.
Okay.
So that I am preparing for that content.
Got it.
So any questions? Arun, Harsh, Joshua?
No, right.
Yeah, I have one more question. So once we deployed to Argo CD, I know it's not working, but the changes that we would have made in the index to HTML, that would have been automatically sent over to our Kubernetes service, right?
Yeah.
Okay. So because I didn't know, we weren't able to verify that, so I just want to. That's the only thing I had.
So once you do the git add, git commit, and git push, okay, automatically that your CI pipeline will run. When CI pipeline get completed, okay, then your CD pipeline will get executed.
Okay.
And here we gave one more loophole, like to Argo CD. So whenever your CI pipeline is running by using GitHub Action, right? What it will do, we have given one of the in the steps that it will go here inside the Helm, and it will do some changes inside your variable. So in the variable, it will replace the tag, correct? So it will replace the tag each and every push. Okay. So this, whenever the tag is changed here, our Argo CD will take care of it. Our Argo CD capture that. If the tag is not updated, your Argo CD will not work at all. So CI part, what it will do, two parts it will do. One is it will build the image and it will push the codes to GitHub. Okay. And third, what it will do, it will go and change your, your GitHub action. What it will do, it will take those information which it received from customer, and it will change the tag value inside the values.yaml. So whenever Argo CD keep on watching to that particular repository, is there any changing happening or not, like that each and every 10 minutes or 5 minutes, Argo CD will keep on watch. When Argo CD come to know that, okay, this tag has been changed in GitHub action. So suddenly what it will do, it will take all the deployments file and it will deploy it onto your Kubernetes cluster.
Okay, I understand. Thank you.
It will accept only tag, other things also it can be accepted.
No, here we have given only tag. Because if you see our see, all these magics are happening by using these steps only. If you see here, we have changed the tag, correct? We have changed the tag. Whenever the tag is changed in this repository,
the command you have given.
The command we have given here. So only tag will change.
That is why we look for tag only. Okay, understood.
Okay, guys, thank you very much. Just remember to share that GitHub repo where you have jotted all the things.
Yeah, so you can zip and you can send it to me so that I can upload in the drive. And
no, it is in public only. If you want to fork it, no problem. I'll share you those information.
Okay.
Can you copy paste that GitHub link in the chat itself?
No, I'll make it private, but I will share all these things to Ravi.
Okay.
Could you also share the PowerPoint?
Yes.
PowerPoint already uploaded in the shared drive.
Okay.
No. The PowerPoint yesterday till what topic we covered, no? Those PowerPoint, those only there. Send you created PowerPoint for Kubernetes. You share this to all.
Okay, sure.
Thank you.
Okay, thank you everyone.
Thank you. Good night.
Thanks.
Thank you.
Thank you.
Thank you, everyone.